What's up, everybody? This is Tech G back with another video to educate you on the AWS Certified Cloud Practitioner exam number CLF-C02. So with that being said, let's get into it. All right, so the AWS Cloud Practitioner exam, this is intended for individuals who can effectively demonstrate overall knowledge of the AWS cloud, independent of a specific job role. This exam validates a candidate's ability to complete the following tasks. So you're going to need to be able to explain the value of the AWS cloud, understand and explain the AWS shared responsibility model, understand security best practices, understand AWS cloud costs, economics, and billing practices, describe and position the core AWS services, including compute, network, database, and storage services, and also identify AWS services for common use cases. All right, next, let's talk about the target candidate. So the target candidate, they have up to 6 months of exposure to AWS cloud design, implementation, and/or operations. Now, this certification is ideal for candidates who are from non-IT backgrounds, and these candidates might be in the early stages of pursuing an AWS cloud career, or they might work with people in AWS cloud roles. And when it comes to recommended AWS knowledge, the target candidate should have AWS knowledge in the following areas, such as AWS cloud concepts, security and compliance in the AWS cloud, core AWS services, and economics of the AWS cloud. All right, next, let's talk about job tasks that are out of scope for the target candidate. So the following list contains job tasks that the target candidate is not expected to be able to perform. Now, just understand that this list is non-exhaustive and these tasks are out of scope for the exam, meaning you don't have to worry about coding, you don't have to worry about cloud architecture design, troubleshooting, implementation, or doing any load and performance testing. All right, so moving on, let's talk about the exam content. So understand that the exam has the following content domains. So you got domain 1, which is cloud concepts, and that's going to take up 24% of the exam. Domain 2, security and compliance, is going to take up 30%. Domain 3, cloud technology and services, that'll take up 34%. And domain 4, billing, pricing, and support, that's going to take up 12% of the exam. Now, when it comes to questions, there are 2 types of questions on the exam. First, you have multiple choice, where you have 1 correct response and 3 incorrect responses, also known as distractors. And then you have multiple response, where you have 2 or more correct responses out of 5 or more response options. Also, unanswered questions, they are scored as incorrect, so there is no penalty for guessing. And the exam includes 50 questions that will affect your score. You also have what is called unscored content. So the exam also includes 15 unscored questions that do not affect your score. So you'll have a grand total of 65 questions to answer. Now, understand that AWS collects information about performance on these unscored questions to evaluate these questions for future use as scored questions. And these unscored questions are not identified on the exam. When it comes to the exam results, the AWS Cloud Practitioner exam has a pass or fail designation, and your results for the exam are reported as a scaled score of 100 through 1,000, and the minimum passing score is 700. And some other details about the exam are as follows. The AWS Cloud Practitioner exam costs about $100 USD. You can take the test online or in person at a Pearson VUE testing center. And the languages the test is available in are Arabic, English, Indonesian, French, German, Italian, Japanese, Korean, Portuguese, Spanish, simplified Chinese, and traditional Chinese. That's what it says on the actual documentation: simplified Chinese and traditional Chinese. So with all that being said, good luck on your exam. All right, so if you've been anywhere near IT, cybersecurity, or even business conversations over the last few years, then you probably heard people constantly talking about the cloud. And more specifically, you probably heard the name AWS come up again and again. But here's the thing. A lot of people jump straight into tools, services, and certifications without really understanding why the AWS cloud is such a big deal in the first place. And that's exactly what this video is about. So I'm going to break down the value proposition of the AWS cloud in terms of why organizations are moving to it, what makes it powerful, and how concepts like economies of scale, global infrastructure, high availability, elasticity, and agility all come together to create one of the most dominant platforms in modern computing. All right, so at its core, the AWS cloud exists to solve a problem that organizations have struggled with for decades. That is how to get reliable, scalable, and secure IT infrastructure without spending a fortune up front. Because back in the day, if a company wanted to launch an application, they had to buy physical servers, set up data centers, hire teams to manage them, and then hope they guessed their fortune growth correctly. Now, if they overestimated demand, then they wasted money on unused hardware. If they underestimated demand, then their systems would crash when traffic increased. So essentially, it was inefficient, expensive, and very risky. But when it comes to AWS, they flipped the entire model on its head. Instead of owning infrastructure, companies can now rent it on demand. So think of it like electricity, where you don't build your own power plant, you just pay for what you use. That's the core value proposition of AWS, on-demand access to computing resources with a pay-as-you-go pricing model. No massive upfront investments, no guessing future capacity. You just spin up what you need when you need it. But that's just scratching the surface, because the real magic happens when you combine all of this with AWS's massive scale, global presence, and built-in resilience. All right, next let's talk about economies of scale. So one of the biggest benefits of the AWS cloud, and a concept that you absolutely need to understand for the exam, is economies of scale. And this is basically the idea that the bigger an operation gets, the cheaper it becomes per unit. And AWS operates data centers at a scale that no single organization can realistically match, because we're talking about millions of servers across the globe. And because AWS buys hardware, power, and networking equipment in massive quantities, they get huge discounts. They then pass those savings on to the customers, and that's why running workloads in AWS is often significantly cheaper than maintaining your own on-premises infrastructure. But it's not just about hardware costs. Think about everything else that goes into running a data center. We're talking about cooling systems, physical security, maintenance staff, network engineers, backup systems, and this list can go on and on. When you use AWS, all of that is handled for you. You're essentially sharing the cost of this massive infrastructure with thousands of other customers, which dramatically reduces your individual costs. Now, another key piece here is the pay-as-you-go model. So instead of buying servers that sit idle most of the time, you only pay for the compute power, storage, and services that you actually use. So if your application needs more resources today, you can scale up and pay more. If it needs less tomorrow, then you can scale down and pay less. That level of cost control is something traditional IT environments simply cannot match. All right, next, let's talk about one of AWS's most powerful advantages, and that is its global infrastructure. So AWS has built an extensive network of regions and availability zones all around the world. And this essentially means that you can deploy your applications in multiple geographic locations with just a few clicks. Now, why does this matter? Well, first, it gives you global reach. So if your users are in North America, Europe, or Asia, you can deploy your applications in all those regions to ensure low latency and better performance. So instead of all users connecting to a single data center halfway across the world, they connect to the closest AWS location. Second, it enables faster deployment. So just imagine launching a startup and needing to expand into new markets. In a traditional environment, you would have to build or lease data center space in each new location. With AWS, you just select a new region and deploy your application there, sometimes within minutes. And another thing concerning global infrastructure is it plays a huge role in disaster recovery. So if something goes wrong in one region, like a natural disaster or a major outage, you can simply fail over to another region and keep your services running. That level of resilience is incredibly difficult and expensive to achieve on your own. All right, next, let's go ahead and talk about high availability, because downtime is an absolute nightmare. So whether you're running an e-commerce site, a banking application, or even a simple blog, if your system goes down, then you lose users, revenue, and trust. And that's where high availability comes in. So when it comes to AWS, it is designed from the ground up to provide high availability through its use of availability zones. And each AWS region contains multiple availability zones, which are essentially isolated data centers with their own power, networking, and cooling systems. And this means that if one AZ experiences an issue, then your application can't continue running in another AZ within the same region. Now, with that being said, you can also design your own applications to run across multiple AZs, ensuring that there's no single point of failure. And this is known as fault tolerance. And the best part, AWS provides the tools and services to make this relatively easy to implement. So for example, You can use load balancers to distribute traffic across multiple servers, databases that automatically replicate data across AZs, and monitoring tools that detect issues and trigger automatic failovers. All of this contributes to a highly available system that can withstand failures without impacting users. Now, one of the most powerful features of the AWS cloud is elasticity. And this is the ability to automatically scale your resources up or down based on demand. So think about a scenario where you run an online store. Now, during normal days, your traffic is steady and manageable. But during a big sale like Black Friday, your traffic suddenly spikes. In a traditional environment, you would have to provision enough servers to handle peak traffic, even if they sit idle most of the year. With AWS, you don't have to worry about that. You can configure your system to automatically scale up when demand increases and scale down when it decreases. And this is often done using services like auto scaling, which monitor your application and adjust resources in real time. And this not only improves performance during high demand periods, but also saves money during low demand periods. So essentially, you're not paying for unused capacity. You're only paying for what you need when you need it. And then that leads us to agility. So if there's one thing that separates successful companies from the rest, well, that will be speed. And basically, that'll be the ability to innovate quickly, test ideas, and bring products to market faster than competitors. That is considered a huge advantage. And that's where agility comes into play. So AWS, this enables organizations to move incredibly fast. So instead of waiting weeks or months to procure and set up hardware, you can launch new servers, databases, and applications in minutes. And this means developers can experiment, build prototypes, and deploy solutions much more quickly. Now, agility, it also supports innovation. So when the cost and effort of trying new ideas are low, organizations are more willing to take risks, and they can test new features, gather feedback, and iterate rapidly. And this leads to better products and a stronger competitive edge. Also, in addition, AWS provides a wide range of managed services like databases, machine learning tools, and analytics platforms. And all of that eliminates the need for complex setup and maintenance. And this essentially allows teams to focus on building applications rather than managing infrastructure. All right, so exactly why does AWS dominate the cloud market? So when you combine all these benefits, we're talking about economies of scale, global infrastructure, high availability, elasticity, and agility, then you can start to see why AWS is such a dominant force in the cloud computing space. It's not just about saving money, although that is a big part of it. It is about transforming how organizations operate. Because companies, they can launch faster, they can scale effortlessly, they can reach global audiences, and they can maintain high reliable systems, all without the burden of managing physical infrastructure. And for startups, this means that they can compete with larger companies without massive upfront investments. And for enterprises, it means that they can modernize their operations, reduce costs, and innovate at a much faster pace. Why does all of this matter for you? Well, if you're studying for the AWS Cloud Practitioner exam, it's easy to get caught up in memorizing definitions. But here's the truth. The exam is really testing whether you understand why the cloud matters. When you see a question about cost savings, think economies of scale and pay-as-you-go pricing. When you see something about global deployment, think AWS regions and availability zones. When you see questions about reliability, think high availability and fault tolerance. And when you see scaling or speed, then think elasticity and agility. And more importantly, if you're trying to break into IT, cybersecurity, or cloud roles, then understanding these concepts will give you a huge advantage because employers are not just looking for people who know AWS services, they're looking for people who understand the business value behind them. All right, so at the end of the day, the AWS cloud isn't just a collection of services. It's a completely different way of thinking about IT. It removes the limitations of traditional infrastructure and replaces them with flexibility, scalability, and efficiency. And the value proposition is simple but powerful. Basically, you access what you need when you need it without the overhead of managing it yourself. Then you add in cost savings through economies of scale, global reach through a massive infrastructure, reliability through high availability, flexibility through elasticity, and speed through agility. And you have a platform that's reshaping the entire technology landscape. So whether you're studying for the exam or building your own tech career, this is one of those foundational concepts that you need to truly understand, because once you do, everything else in AWS starts to make a whole lot more sense. All right, so with that being said, let's do some check on learning. So our first question is, which of the following best describes the economies of scale benefit provided by AWS Cloud? Is it the ability to run applications globally without managing hardware? Is it the ability to reduce costs as more customers use AWS services? Is it the ability to automatically scale resources to match demand? Or is it the ability to store unlimited data at no additional cost? And the correct answer is it is the ability to reduce costs as more customers use AWS services. So economies of scale simply means that AWS can purchase large amounts of infrastructure and resources at lower prices, passing those savings on to customers. And this leads to lower costs compared to building and maintaining on-premises infrastructure. Next question. Which of these is a key advantage of AWS's global infrastructure? Is it AWS customers can host resources only in their local country? Is it deployment of resources is limited to one region at a time? Is it the ability to deploy applications close to end users for lower latency and faster performance? Or is it customers must manually transfer data between regions? And the correct answer is it is the ability to deploy applications close to end users for lower latency and faster performance. So AWS's global infrastructure allows customers to deploy applications in multiple AWS regions and availability zones worldwide. And this provides faster access and lower latency for users regardless of their location. And our final question is, which combination of features helps AWS customers rapidly adjust to changing business needs? Is it high availability, elasticity, and agility? Is it data redundancy, automatic backups, and on-premises security? Is it reserved instances, manual scaling, and low-speed storage? Or is it single availability zone deployment and static IP addresses? And the correct answer is high availability, elasticity, and agility. So high availability, this ensures systems are reliable. Elasticity, this allows resources to automatically scale up or down as demand changes. And agility, this allows businesses to innovate quickly without long procurement cycles or large upfront investments. When most people start studying for the AWS Cloud Practitioner exam, they think it's going to be all about memorizing services like EC2, S3, or Lambda. And yeah, those do matter. But what AWS really cares about is how you design systems in the cloud. Because here's the truth. Anyone can spin up a server, but not everyone can build something that's secure, reliable, cost-effective, and scalable at the same time. And that's where the AWS Well Architect framework comes in. So think of it like a blueprint, or better yet, like a set of best practices that AWS engineers use to build systems that don't fall apart under pressure. And if you understand this framework, then you're not just studying for an exam, you're learning how real-world cloud architecture works. So with that being said, let's get into it. All right, so exactly what is the AWS Well Architect framework? Well, at its core, the AWS Well Architect framework, this is a collection of design principles and best practices that help you build high quality cloud systems. So instead of guessing what good architecture looks like, AWS gives you a structured way to evaluate your environment across 6 key pillars. We're talking about operational excellence, security, reliability, performance efficiency, cost optimization, and sustainability. And each pillar represents a different lens you should look through when designing or reviewing your system. So think of it like building a house. When it comes to security, we're talking about locks, alarms, and cameras. When it comes to reliability, we're talking about a strong foundation. When it comes to performance, we're talking about good plumbing and electricity. When we're talking about costs, we're talking about staying within budget. When it comes to sustainability, we're talking about energy efficiency. And when we're talking about operations, we're talking about maintenance and upkeep. Now, if one of those is weak, then the whole system will suffer. All right, so before we even dive into the pillars, AWS has some core design principles that apply across everything. And the first one is the stop guessing capacity, where you use scalable services instead of over provisioning. Another one is test systems at production scale, where you don't assume, you validate everything. Another one is automate everything that you can, and this helps to reduce human error. Another one is you want to use what is called loose coupling. This is where systems should not depend too tightly on each other. Then you have design for failure, because you want to assume that things will break. You also want to implement elasticity, and this is when you're scaling up or down automatically. And you also want to use managed services, because this lets AWS handle the heavy lifting. So in essence, these principles are what make cloud environments different from traditional on-premises environments. All right, so let's talk about our first pillar, and that is operational excellence. So operational excellence, this is all about running and improving your systems effectively. In simple terms, it means, can you manage your environment without chaos? And this pillar focuses on things like automation, monitoring, logging, and continuous improvement. So instead of manually configuring servers, AWS encourages you to use tools like infrastructure as code, so everything is repeatable and consistent. So as an example, just imagine you're running a website and it crashes at 2 a.m. Without operational excellence, you might panic, log in, and try some random fixes. With operational excellence, the alerts will trigger, the logs will show the issue, and the automation will go about the business of recovering the system. That's the difference between reacting and being prepared. Then there's pillar 2, and that is security. So security, this is probably the most talked about pillar, and for good reason. This pillar focuses on protecting your data, systems, and assets. And key concepts include identity and access management, encryption, monitoring and logging, and incident response. In AWS, this operates on a shared responsibility model where AWS secures the cloud or the infrastructure, and you secure whatever you put in the cloud. So as an example, let's say if you leave an S3 bucket public with sensitive data, well, that's not AWS's fault. That's a design failure. Security is about designing systems so mistakes are minimized and damage is limited. Then there's pillar number 3, and this is reliability. So reliability, this is all about keeping your system running, even when things go wrong. And guess what? Things will go wrong. And this pillar focuses on fault tolerance, recovery, redundancy, and backup strategies. And AWS encourages you to design systems that can survive failures and not avoid them entirely. So as an example, instead of you running one server, you deploy across multiple availability zones, you use load balancers, and you implement automatic failure. So if one part fails, the system will keep running, and that's reliability in action. And then there's pillar number 4, and this is performance efficiency. And this is about using resources efficiently to meet system requirements. So in other words, don't just make it work well. And this includes choosing the right services, scaling resources dynamically, and monitoring performance. In AWS, it gives you flexibility to use different compute options like EC2, Lambda, containers, and a whole bunch of other stuff. So as an example, instead of you running a large server 24/7, you can go serverless by using Lambda for event-driven tasks, and you can scale automatically based upon your demands. And this ensures that you're not wasting resources or, more importantly, money. Then there's pillar number 5, and we're talking about cost optimization. And this is everyone's favorite pillar because nobody likes surprise cloud bills. And cost optimization is focused on getting the best value for your money. And key practices include pay-as-you-go pricing, right-sizing resources, monitoring usage, and eliminating waste. An example of this will be, let's say that you leave unused EC2 instances that are running. Well, you are literally paying for nothing. So instead, you want to use auto scaling, you want to shut down unused resources, and you want to use reserved instances where appropriate. Because at the end of the day, a smart design equals a lower cost. All right, and then that leads us to pillar number 6, and that is sustainability. And this is the newest pillar, and it's becoming increasingly important because sustainability, this focuses on reducing environmental impact. And this includes efficient resource usage, minimizing energy consumption, and using scalable services. An example of this would be something like running oversized servers all the time. Well, that's going to waste a lot of energy. Well, using serverless or auto scaling, this reduces compute usage and lowers your carbon footprint. So you're not just saving money, but you're also helping the environment as well. All right, so here's where a lot of people get tripped up because you need to understand how these pillars are different from each other. So let me go ahead and break this down clearly. When it comes to operational excellence, we're talking about how do you manage and improve systems. When it comes to security, we're talking about how do you protect systems and data. When it comes to reliability, we're talking about how do you keep your systems running. When it comes to performance efficiency, we're talking about how well your systems use resources. When it comes to cost optimization, we're talking about how much do you spend. And when it comes to sustainability, we're talking about the overall environmental impact. So another way to put this is, think of a car. When it comes to operational excellence, you're talking about maintenance and monitoring. Security, we're talking about locks and anti-theft systems. Reliability, we're talking about your engine durability. performance, we're talking about speed and fuel efficiency. Cost, we're talking about the price of ownership. And sustainability, we're talking about fuel emissions. Now, each pillar focuses on a different aspect, but they all work together. And here's the key thing AWS wants you to understand. You cannot optimize one pillar at the expense of another. So for example, maximizing performance, this might increase costs, and cutting costs too much, this might reduce reliability, and increasing security, this might add complexity. The goal that you want to achieve here is some type of balance, because good cloud architecture is all about making trade-offs intelligently. All right, so let me go ahead and wrap all this up. So let's say you're building a web application. Well, a well-architected design would do something like this. When it comes to operational excellence, they're going to automate deployments using CI/CD. When it comes to security, they're going to use identity and access roles, encryption, and secure APIs. When it comes to reliability, we're talking about multi-AZ deployment and backups. When it comes to performance, we're talking auto scaling and caching. Cost optimization, we're talking about right-sized instances and going serverless where possible. And when it comes to sustainability, we're talking about efficient resource usage. Now, if you apply all of that stuff in the correct way, then you're not just building an application, you're building it the right way. Now, understand, for the AWS Cloud Practitioner exam, you do not need to design complex architectures, but you do need to recognize each pillar, understand what each one focuses on, identify scenarios that relate to each pillar, and understand their trade-offs. So expect questions like which pillar focuses on cost control, which pillar is responsible for fault tolerance, and which pillar involves monitoring automation. And if you understand the concepts and not just memorize the definitions, then you're more than likely going to succeed in passing those questions. All right, so with all that being said, let's do some check on learning. So our first question is, which AWS Well Architect Framework pillar focuses on monitoring systems, continuous improvement, and automating changes? Is this reliability, operational excellence, security, or sustainability? And the correct answer is operational excellence. So the operational excellence pillar emphasizes monitoring systems, automating changes, and continuous improvement to deliver business value and support development and operations efficiently. Next question. Which of the following best describes the difference between the security and reliability pillars of the AWS Well Architect Framework? Is it security focuses on cost optimization, while reliability focuses on securing data? Is it security focuses on protecting systems and data, while reliability focuses on recovery and maintaining workloads despite disruptions? Is it reliability focuses on encryption, while security focuses on performance efficiency? Or is it security and reliability are the same and focus on operational excellence? And the correct answer is security focuses on protecting systems and data, while reliability focuses on recovery and maintaining workloads despite disruptions. So the security pillar, this is all about protecting systems and data using identity and access management, encryption, and detection controls. The reliability pillar, this is about ensuring a workload performs as expected and can recover from failures and disruptions. And our final question is, which pillar of the AWS Well Architect Framework is most concerned with minimizing environmental impacts through efficient resource usage? Is it cost optimization, performance efficiency, sustainability, or operational excellence? And the correct answer is sustainability. So the sustainability pillar focuses on environmental responsibility, aiming to reduce energy consumption, improve efficiency, and minimize the environmental impact of cloud workloads. Moving to the cloud, this is one of those phrases that gets thrown around a lot in IT. You hear it in meetings, job postings, certifications, and probably every tech YouTube video that you scroll past. But what does it actually mean to migrate to the cloud? And more importantly, why should businesses care? Well, if you're preparing for the AWS Certified Cloud Practitioner exam, then this is one of those foundational topics that you absolutely need to master. So in this video, I'm going to break it all down for you. So with that being said, let's get into it. All right, so let's go ahead and start with the big question. Why are companies leaving traditional data centers and moving to AWS? Well, think about a traditional on-premises environment. You got servers sitting in a data center somewhere. You had to buy that hardware up front, which isn't cheap. You got to maintain it, cool it, secure it, and upgrade it every few years. Well, that's a lot of responsibility and a lot of money. Now compare that to AWS. Instead of owning the infrastructure, you're essentially renting it. You spin up resources when you need them, shut them down when you don't, and only pay for what you use. That alone is a game changer, but it goes deeper than just cost. So let's talk about cost optimization and financial flexibility. So one of the biggest benefits of migrating to AWS is shifting from capital expenditures to operational expenditures. So instead of dropping thousands or millions on hardware up front, you simply pay as you go. And this allows businesses to scale resources up or down based on demand, avoid over-provisioning hardware, reduce wasted capacity, and improve cash flow. And for startups and growing companies, this is huge because you don't need a massive upfront investment to build enterprise-level infrastructure anymore. Then there's scalability and elasticity. So let's say your website suddenly goes viral in a traditional environment that could crash your servers. At AWS, you scale instantly because AWS provides elastic scalability, meaning your resources can automatically expand or shrink based on demand. And this ensures better performance during peak traffic, cost savings during low usage, and no need for manual intervention. And this is one of the key reasons companies like Netflix rely heavily on cloud infrastructure. There's also improved security and compliance. Now, I know what you might be thinking. Isn't putting data in the cloud less secure? Well, it's oftentimes the complete opposite. AWS invests billions into security infrastructure. They provide encryption at rest and in transit. They provide identity and access management, compliance with global standards like HIPAA and GDPR, and continuous monitoring and threat detection. Plus, AWS operates under a shared responsibility model, meaning AWS secures the cloud infrastructure while you secure what you put in it. There's also global reach and high availability. So with AWS, you're not limited to one physical location. AWS has regions and availability zones all over the world, allowing businesses to deploy applications closer to users, reduce latency, and improve performance, in addition to achieving high availability and fault tolerance. So if one data center goes down, your application can still run from another, and that is very powerful. And then there's ESG and sustainability benefits. So this is something that a lot of people overlook. So migrating to AWS can actually improve a company's environmental, social, and governance performance. And AWS data centers are designed to be more energy efficient than traditional setups. And by moving to the cloud, companies can reduce their carbon footprint, lower energy consumption, and support sustainability initiatives. And in today's world, that matters a lot. All right, so now that we know why companies move to AWS, let's talk about how they actually do it. Because here's the thing, cloud migration isn't just flipping a switch. It's a journey, and every organization takes a slightly different path. So let's talk about the AWS Cloud Adoption Framework. So AWS created something called the Cloud Adoption Framework to help guide organizations through their cloud journey. So think of it like a roadmap. It breaks down cloud adoption into different perspectives, including business, people, governance, platform security, and operations. And the goal is to help organizations align their IT strategy with business goals while minimizing risk. And when using the AWS Cloud Adoption Framework, this can provide several advantages. The first is reduced business risk. So instead of rushing into cloud migration blindly, CAF, it helps organizations plan properly, identify risks, and implement controls. There's also increased operational efficiency. So by modernizing infrastructure and automating processes, businesses can operate faster and more efficiently. There's increased revenue opportunities because cloud enables faster innovation. Well, this can allow companies to launch new products and servers quickly. And then there's improved ESG performance. So like I mentioned earlier, cloud adoption supports sustainability goals. All right, next let's go ahead and talk about the cloud migration journey. So understand migration, this isn't a one-step process. It typically happens in phases. The phase one is the assess phase. So before anything gets moved, organizations need to understand their current environment. And this includes identifying applications and workloads, evaluating dependencies, and determining readiness for the cloud. And tools like the AWS Migration Evaluator, it can help out with this. Phase two is when you begin to mobilize. So this is where planning gets serious because organizations, they got to build a migration plan. They got to train their staff. They got to set up AWS accounts and security configurations. And they also have to establish governance policies. And then there's phase three, where it is actually time to begin the migration. So your applications and data are then moved to AWS using different strategies, which I will talk about next. All right, so AWS migration strategies, they are often referred to as the 6 R's. So let me go ahead and explain them. So the first R stands for rehost, and this is the simplest approach. And basically, you take your application and move it to AWS without making major changes. So think of it like picking up your house and dropping it in a new neighborhood. And this is best for quick migrations and legacy applications. You also have what is called replatform, and here you make small optimizations during migration. So for example, you're moving from a self-managed database to Amazon RDS, and this is best for improving performance without major redesigns. The next R stands for repurchase, and this means replacing your existing system with cloud-based solutions. So an example of this could be moving from a local CRM to Salesforce. You also have what's called refactor, and this is the most complex approach because you basically have to redesign the application to fully take advantage of the cloud features, and this is best for long-term scalability and innovation. You have what is called retire. So some applications just aren't needed anymore. So instead of migrating them, you just simply get rid of them. And then you have what is called retain. So some systems need to stay on premises due to compliance requirements and technical limitations. Now, AWS does provide a ton of tools to help with migration. So let's go ahead and talk about some of the important ones. The first one is called AWS Snowball. So what if you have massive amounts of data, like terabytes or petabytes of data? Well, uploading that over the internet could take forever. And that's where AWS Snowball comes in. So basically, AWS ships you a physical device. You load your data onto it, send it back, and AWS uploads it into your environment. And the use case for this will be large-scale data transfers and limited bandwidth environments. You have what is called database replication. So migrating databases, this is a big deal. And AWS provides services like AWS Data Migration Services, where this allows you to replicate data in real time, minimize downtime, and ensure data consistency. Then there's the AWS Migration Hub, and this tool helps you track your migration progress in one place. So think of it like a dashboard for your entire migration project. You also have AWS Application Discovery Services, and this helps you understand your existing environment by collecting data about your servers, applications, and dependencies. All right, so let's go ahead and talk about choosing the right strategy. So understand that there is no one-size-fits-all solution. The right migration strategy, all of this depends upon your business goals, your budget, your timeline, your application complexity, and your compliance requirements. So for example, a startup, they might go all in with refactoring. On a large enterprise, they might start with rehosting. All right, next, let's talk about some challenges that are associated with cloud migration, because migration is not always smooth. And some common challenges include a lack of cloud skills, security concerns, downtime risks, cost mismanagement, and legacy system compatibility. But with the proper planning and frameworks like AWS CAF, well, these challenges, they can be managed effectively. All right, so let me go ahead and wrap all this up. So if you're studying for the AWS Cloud Practitioner exam, here's what you really need to lock in on. You need to understand that cloud migration, this essentially equals moving workloads from on-premises to AWS. Benefits, we're talking about cost savings, scalability, security, global reach, and ESG. AWS Cloud Adoption Framework, just understand that this is a framework for successful cloud adoption. You got your migration strategies. We're talking about the 6 R's, and we got various tools to help all this stuff happen, like Snowball, DMS, Migration Hub, and Discovery Service. So here's the bigger picture. Cloud is not the future anymore. It is the present. So whether you're going into help desk, system administration, networking, or cybersecurity, you're going to touch cloud environments. And understanding migration isn't just about passing an exam. It's about understanding how modern IT actually works. And if you can confidently explain why companies move to AWS, how they plan migrations, and what strategies they use, then you will be ahead of a lot of people in the field. All right, so with all that being said, let's do some check on learning. So our first question is, a company wants to move its on-premises applications to AWS as quickly as possible with minimal changes to the application architecture. Which migration strategy should the company use? Should it be refactoring, replatforming, rehosting, or repurchasing? And the correct answer is rehost. And this is also known as lift and shift. And this involves moving an application to AWS without making significant changes. And this is the fastest and simplest migration strategy. So if you see a question that has the words quick migration or minimal changes, they're more than likely talking about rehost. Next question. Which of the following is a key benefit of using the AWS Cloud Adoption Framework? Is it eliminates the need for security controls in the cloud? Is it helps organizations align cloud adoption with business goals and reduce risk? Is it automatically migrates applications to AWS? Or is it replaces all existing on-premises infrastructure immediately? And the correct answer is it helps organizations align cloud adoption with business goals and reduce risk. So the AWS Cloud Adoption Framework, this is designed to guide organizations through cloud adoption by aligning IT strategy with business objectives. And the key benefits include reduced business risk, improve operational efficiency, increased revenue opportunities, and better ESG performance. And our final question is, a company needs to migrate petabytes of data to AWS but has limited internet bandwidth. Which AWS service is the most appropriate solution? Would this be AWS Lambda, Amazon EC2, AWS Migration Hub, or AWS Snowball? And the correct answer is AWS Snowball. So AWS Snowball, this is a physical data transfer device used to move large amounts of data into AWS when network transfer is too slow or impractical. And this is ideal for large-scale data migrations and or limited bandwidth environments. All right, so when most people hear cloud computing, they think about servers, storage, networking, and maybe security. But what often gets overlooked and what AWS really wants you to understand for this exam is this: the cloud isn't just a technical shift, it's a financial transformation. We're talking about a completely different way of thinking about costs, budgeting, scaling, and even how businesses grow. So let me go ahead and explain how companies use AWS to save money and make smarter decisions. All right, so first things first, what is cloud economics? Well, cloud economics, this is all about understanding how cloud services impact costs compared to traditional IT infrastructure. So in other words, how does AWS help businesses spend less, scale smarter, and operate more efficiently? And if you're going into IT, this matters more than you think, because guess what? At some point in your career, you will not just be configuring servers. You will be expected to justify costs, optimize resources, and maybe even explain to leaders why moving to the cloud makes financial sense. All right, so before we can understand cloud economics, we need to understand what companies are moving away from. So let's talk about on-premises environments. So picture a company that has its own data center. Within it, they're going to have physical servers, storage arrays, networking equipment, cooling systems, backup power supplies, and of course, they're going to need an IT staff to maintain everything. And all of that sounds expensive because at the end of the day, it is. Now, understand that most people think the cost is just buying servers, but that's only the beginning. Here's what companies actually pay for. They're paying for hardware purchases like servers, storage, and networking gear, data center space, whether they're renting something or building it, power and cooling, maintenance and repairs, and software licensing, in addition to backup and disaster recovery systems, security infrastructure, and IT staffing and labor. And here's the kicker for all of this. You have to pay for all of this up front, whether you fully utilize it or not. All right, so if there's one concept that you need to lock in for this exam, it's this. You need to understand fixed costs versus variable costs. So what is a fixed cost? Well, we're talking about on-premises stuff. So fixed costs, these are expenses that do not change based upon usage. Examples of this could be buying servers, leasing a data center, or purchasing networking equipment. So whether you use the servers or not, you already paid for them. Do you have what are called variable costs? And we're talking about the cloud. So with variable costs, you simply pay as you go. And with AWS, you only pay for what you use, you scale up or down instantly, and you're not locked into unused capacity. And this is one of the biggest advantages of cloud computing. So why does this matter? Well, let's say a company prepares for peak traffic and buys 10 servers, but most of the time they only need 3 of them. That means 7 servers are just sitting there doing nothing, but they still cost money. With AWS, you only run what you need, and that right there is cloud economics in action. All right, so let's talk about the cost savings of moving to the cloud and why some companies actually save money with AWS. The first reason is no upfront hardware costs, meaning you don't need to buy servers anymore. That alone can save thousands of dollars for small businesses or even millions for enterprises. Once again, there is the pay-as-you-go pricing model. So you're only billed based upon compute usage, storage consumption, and data transfer. So essentially, you're not wasting any resources and you're not guessing your way through this. Another benefit is reduced operational costs because AWS handles the hardware maintenance, the data center operations, and the physical security, which means fewer IT overhead costs. Then there's economies of scale. And this basically means AWS operates at a massive scale. And because of that, they can offer services at lower prices that most companies could not achieve on their own. All right, next let's talk about licensing strategies. Now, this is another exam favorite. So when migrating to AWS, companies, they have choices about software licensing. And the first one is called BYOL, or bring your own license. And with BYOL, you are taking your existing software licenses and using them in the cloud. Examples of this could be your Windows Server licenses or your SQL Server licenses. And the benefits are it offers cost savings if you already own the licenses, and it offers flexibility. And then there's where your licenses are included. So AWS can provide the licenses as part of their service. Examples could be Amazon EC2 with Windows licensing that is included, and managed databases that have built-in licensing. And the benefits are it offers a simpler setup. There's no license management headaches. And essentially the key takeaway that you need to understand is this. When it comes to BYOL, or bring your own license, this is essentially what you already own, and licenses included. This is what AWS handles for you. All right, so let's talk about something that sounds simple but has a huge impact, and that is right sizing. And right sizing, this means choosing the correct size and type of resource based on your actual needs. So here's the thing. You have a problem, and the problem is called over provisioning. And what happens with this? Well, companies, they often choose larger resources than needed just in case. An example could be running a large EC2 instance when a smaller one would work. At the end of the day, that is wasted money. Well, the solution is called right sizing. And with AWS, you can monitor your usage, adjust resources, and scale up or down as needed. An example of this could be if your application only uses 20% of CPU, then why would you pay for 100%? Well, right sizing will fix that. Now, as an exam tip, just understand that right sizing, this is cost optimization through proper resource selection. Now, here's where things can get really powerful. We're talking about automation, and understand that automation is not just about convenience, it's about saving money. So we have AWS Cloud Formation. Basically, this allows you to define infrastructure using code. So instead of manually setting things up, you create templates, you automatically provision resources, and all of that ensures consistency. And how does this help you save money? Well, this reduces human error, it speeds up deployment, it prevents misconfigurations, and it eliminates unnecessary resources. So as an example, instead of leaving test servers running overnight, automation can shut them down automatically and restart them when needed, and that will contribute to direct cost savings. Then there's the concept called managed services. So AWS offers managed services, which means AWS handles the heavy lifting for you. And this is a big deal in cloud economics. So within that, we have what is called Amazon RDS, or Relational Database Service. So instead of managing your own database server, AWS handles your backups, your patching, and your scaling. And basically, it produces less work, which equals less operational costs for you. You also have what is called Amazon DynamoDB, and this is a fully managed NoSQL database where you have no server management. It offers automatic scaling and high availability. And then you also have Amazon ECS, which stands for Elastic Container Service, and this is used for running containers without managing infrastructure. You also have what is called Amazon EKS, and that stands for Elastic Kubernetes Services. And this allows you to manage Kubernetes services. And basically, Amazon handles the control plane, the updates, and the scaling. Now, why do these managed services even matter? Well, instead of hiring a large team to manage the infrastructure, you let AWS do it. That means you have lower labor costs, faster deployment, and reduced complexity. All right, so let's go ahead and connect all the dots on this. So cloud economics, this is really about spending smarter, not just spending less. And with AWS, businesses, they can replace fixed costs with variable costs. They can avoid upfront investments. They can optimize resources through right sizing. They can automate operations to reduce waste, and they can use managed services to reduce their labor. Now, with all that being said, just understand that companies do not automatically save money by just moving to AWS. Some common mistakes that some companies make are as follows. They leave resources running unnecessarily. They over-provision instances. They do not use automation, or they ignore cost monitoring tools. Now, the cloud can save you money, but only if you manage it properly. All All right, so here's what you need to remember for the exam. Understand cloud economics. We're talking about cost optimization in the cloud. When it comes to fixed costs, we're talking about on premises, such as your hardware and your data centers. When it comes to variable costs, we're talking about AWS, like pay as you go. You also have to understand the difference between BYOL, bring your own license, versus licenses included. You got a concept called right sizing. This is where you get to choose the correct resources you need. You have automation, where this can reduce your costs and errors. And you got managed services, which will translate into less operational overhead. Because here's the bigger picture. Cloud economics, this isn't just for accountants or managers. It's for you, because as an IT professional, you're going to be asked questions like, why are we spending so much on AWS? Can we reduce these costs? Is the architecture efficient? And if you can answer those questions confidently, then you instantly become more valuable. So just understand that cloud computing changed how we build infrastructure, but cloud economics, that changed how we think about money in IT. And once you understand it, you don't just see servers and services. You see cost, efficiency, scalability, and opportunity. All right, so with all that being said, let's do some check on learning. So our first question is, a company wants to reduce large upfront infrastructure expenses and instead pay only for the resources they actually use. Which cloud economics concept best describes the benefits of AWS? Is this the fixed cost model, the variable cost model, capital expenditure increase, or over provisioning? And the correct answer is variable cost model. So the variable cost model, this is a core concept of cloud economics. With AWS, you pay only for what you use, known as pay as you go, and this eliminates large upfront investments. Next question. A company migrates its applications to AWS and uses Amazon RDS instead of managing its own database servers. Which cloud economics benefit does this best represent? Is this increased capital expenditures, higher licensing costs, fixed infrastructure scaling, or reduced operational overhead through managed services? And the correct answer is reduced operational overhead through managed services. So Amazon RDS, this is a managed service, meaning AWS handles backups, patching, maintenance, and scaling. And this reduces the need for in-house management and lowers operational costs. And our final question is, a company notices that its EC2 instances are consistently underutilized and decides to switch to smaller instance types to better match workload requirements. Which cloud economics concept is being applied? Is this bring your own license? Is this right sizing, refactoring, or high availability? And the correct answer is this is right sizing. So right sizing, this simply means selecting the appropriate resource size based on actual usage. And this prevents overpaying for unused capacity, and it improves cost efficiency. Moving to the cloud does not mean you're off the hook for security. Now, this is one of the biggest misconceptions that beginners have when they first start learning about cloud computing, especially with AWS, because a lot of people assume, well, AWS handles everything, right? Well, not exactly. Now, what AWS gives you is what is called shared responsibility, not total responsibility. And if you're preparing for the AWS certification exam, then you must understand this concept inside and out. So think of it like renting an apartment. The landlord, or AWS, they are responsible for the building, the structure, the plumbing, and the electrical systems. But inside your apartment, all of that's on you. And if you leave the door unlocked or you don't clean up, well, that is your responsibility and not the landlord's. And that's exactly how AWS works. All right, so what is the AWS shared responsibility model? Well, at its core, the AWS shared responsibility model, this defines who is responsible for what when it comes to security and compliance in the cloud. Now, AWS, it splits responsibilities into two main categories. You got security of the cloud, which is AWS's responsibility. Then you have security in the cloud, which is the customer's responsibility. And this distinction is critical. So let's talk about security of the cloud. So AWS, they are responsible for protecting the infrastructure that runs all the AWS services. And this includes physical data centers, hardware like servers, storage devices, and networking equipment, your global infrastructure, where we're talking about regions and availability zones, and the virtualization layer, also known as the hypervisor. So in other words, AWS, it secures the foundation. And then there's security in the cloud. So you, the customer, you are responsible for everything that you deploy and configure inside of AWS. This includes the operating systems, the applications, the data, identity and access management, and your network configurations like your security groups and firewalls. So while AWS builds the house, you are responsible for locking the doors and securing your belongings. All right, so to really understand this model, you need to recognize its components and how they interact. And the first is the physical security. So once again, AWS, they handle the data center access controls, they do surveillance and monitoring, and they do environmental protections when it comes to fire suppression and power redundancy. So basically, you don't have to worry about someone walking into an AWS data center and unplugging your server. That's AWS's job. Another thing is infrastructure security. And this includes networking infrastructure, hardware maintenance, and hypervisor patching. So AWS basically ensures that the underlying systems are secure and resilient. And then there's the platform and application layer. And this is where your responsibility kicks in. So you're responsible for installing updates on EC2 instances, securing your applications, and managing your runtime environments. Because if your application gets hacked because you didn't patch it, well, that's on you. There's also data security. So your data is always your responsibility, and this includes encryption, backups, data classification, and data lifecycle management. Now, AWS, they provide tools like encryption services, but you must use them correctly. And then there's identity and access management. So one of the biggest areas where beginners make mistakes are as follows. They don't create secure identity and access management policies. They do not enforce least privilege, and they fail to manage their user credentials. So if someone gains unauthorized access because of your weak policies, then AWS is not responsible. You are. All right, so let's zoom in on AWS's side of the equation. So just understand that AWS, they are responsible for the physical data center security, the global infrastructure like your regions and AZs, the hardware and networking equipment, the hypervisor and virtualization layer, and the managed service infrastructure. However, they also ensure compliance certifications like SOC, ISO, and other ones. They also deal with high availability and fault tolerance and infrastructure monitoring. Now, this is often referred to as security of the cloud. And honestly, this is where AWS shines because they invest billions into infrastructure security, which is far more than most organizations ever could. Now let's talk about your side of the equation because this is where people get tripped up. As a customer, you are responsible for data protection when it comes to encrypting sensitive data, managing backups, and ensuring compliance with HIPAA, GDPR, and some other policies. You're also responsible for identity and access management when it comes to creating users and roles, applying least privilege principles, and managing your credentials. You're also responsible for your operating systems when it comes to patching and updating your EC2 instances and securing your configurations. You're also responsible for application security when it comes to writing secure code, fixing any vulnerabilities, and monitoring application behavior. And you're also responsible for network configuration when it comes to setting up security groups, network ACLs, and firewall rules. This is known as security in the cloud. All right, next, let's talk about some shared responsibilities. So some responsibilities are shared between AWS and the customer. And some examples are as follows. We're talking about patch management, and this depends upon the service that you're using, configuration management, security monitoring. So for example, AWS, they're going to provide tools like CloudWatch and CloudTrail, but you must configure and monitor them properly. So basically, AWS is going to give you the tools, but you have to use them correctly. All right, next, let's talk about how the responsibilities shift based upon the AWS service. Now, this is one of the most important concepts for the exam because your level of responsibility changes depending upon the type of service that you use. So let me go ahead and break all this down. You have Amazon EC2. And basically with Amazon EC2, you have the most control and the most responsibility. So AWS, they're going to handle the physical hardware, the data centers, and the networking infrastructure. You're going to handle the operating system updates, application security, data encryption, firewall configurations. So basically think of EC2 as renting a bare apartment where you have to furnish and secure everything that goes inside of it. Then there's Amazon RDS. Now, with Amazon RDS, AWS takes on more responsibility. So basically, AWS handles database software patching, some backups if configured, and the overall infrastructure. You handle the database configuration, the access controls, and the data security. So now AWS is helping you to manage the database engine, but you still control access and data. And then you have AWS Lambda. So with AWS Lambda, AWS handles almost everything. They handle the servers, the operating system, scaling, and the runtime environment. You just handle the code, permissions, and the data. And this is where your responsibility is minimized, but it is not eliminated. All right, so here's the key takeaways that you need to understand. More abstraction equals less responsibility. So basically, the more AWS manages, the less you manage, but you never reach zero responsibility. So how do you explain all of this in a job interview? So if someone asks you, what is the AWS shared responsibility model? Well, you can respond by saying the following. It's a model that defines how security responsibilities are divided between AWS and the customer. AWS is responsible for securing the cloud infrastructure, while the customer is responsible for securing what they run in the cloud, such as their data, applications, and configurations. The exact responsibilities, they shift depending upon the service that is being used, like EC2, RDS, or Lambda. And if you give that answer, then guess what? You're probably going to get hired, because at the end of the day, the AWS shared responsibility model, this is all about ownership. Moving to the cloud does not eliminate responsibility. It redefines it. In AWS, it gives you a secure infrastructure, powerful tools, and global scalability, but you still need to configure your systems properly, protect your data, manage your access, and monitor your environment. So if you understand this concept deeply, that you're not just preparing for the exam, you're preparing for real world success in cloud computing. So with all that being said, let's do some check on learning. So our first question is, which of the following is AWS's responsibility under the shared responsibility model? Is it configuring IAM user permissions? Is it patching the operating system on an EC2 instance? Is it encrypting customer data? Or is it securing the physical data centers? And the correct answer is securing the physical data centers. So AWS is responsible for security of the cloud, which includes physical infrastructure like data centers, hardware, and networking, and tasks like IAM configuration, operating system patching, and data encryption. All of that falls up under the customer's responsibility. Next question. A company is running an application on Amazon EC2 and fails to install critical security updates on the operating system. Who is responsible for this issue? Is it AWS, the customer, both AWS and the customer, or the AWS support team? And the correct answer is the customer. So with Amazon EC2, which is an infrastructure as a service, AWS manages the underlying infrastructure, but the customer is responsible for the operating system, including the patching and updates. And this is a classic example of security in the cloud, which remains the customer's responsibility. And our final question is, how does the shared responsibility model change when moving from Amazon EC2 to AWS Lambda? Is it the customer becomes responsible for more infrastructure? Is it AWS takes on more responsibility, therefore reducing customer responsibility? Is it their responsibilities remain exactly the same? Or is it the customer is no longer responsible for anything? And the correct answer is AWS takes on more responsibility, reducing customer responsibility. So as you move from infrastructure as a service to serverless like AWS Lambda, AWS manages more components such as the operating system, runtime, and scaling. However, the customer is still responsible for their code, data, and permissions. All right, so when people first start learning cloud computing, especially with AWS, one of the biggest concerns that always comes up is security, and rightfully so, because you're moving data, applications, and sometimes entire infrastructures into someone else's environment. So the natural question becomes, how secure is this really? And that's exactly what this objective is all about, which is understanding how AWS approaches security, how governance is enforced, and how compliance is maintained across industries and regions. So with that being said, let's go. All right, so before we can even talk about tools, logs, or encryption, you need to understand one core concept, and that is the shared responsibility model. And this is probably one of the most important ideas you'll see, not just on the exam, but in real world cloud environments. So basically, AWS is responsible for security of the cloud, and that includes your physical data centers, networking infrastructure, hardware, and global infrastructure like regions and availability zones. You, as the customer, you are responsible for security in the cloud. That includes your data, your applications, identity and access management, and configuration of your services. So think of it like renting an apartment. The landlord, which is AWS, they secure the building, but you're responsible for locking your front door. And this model is crucial because many beginners assume AWS handles everything, when in fact it does not. And understanding where your responsibility starts is a major part of governance and compliance. All right, so let's talk about governance and compliance. Now, these are often confused, but they serve slightly different purposes. Governance, this is about control, making sure your cloud environment follows internal policies. Compliance, this is about meeting external requirements, such as laws, regulations, and industry standards. And AWS provides a ton of support in this area, especially through tools like AWS Artifact. And basically, AWS Artifact, this is essentially your compliance document library. It gives you access to SOC reports, ISO certifications, PCI DSS compliance documents, and HIPAA eligibility details. So in the real world, if you're working for a company in healthcare or finance, you'll constantly be asked, is AWS compliant with XYZ regulation? In AWS Artifact, this is where you go to prove it. All right, next let's talk about compliance across regions and industries. So one thing that trips people up is that compliance is not universal. It can vary based upon geographic location, like the GDPR in Europe, or the industry when it comes to things like HIPAA for healthcare or PCI DSS for payment processing. And AWS addresses this by offering region-specific infrastructure and compliance programs. So for example, if you need to meet European data protection laws, you might store data in the EU region. However, if you're handling credit card data, then you'll need PCI DSS compliance services. And this is where AWS shines because its global infrastructure that allows you to architect solutions that meet very specific compliance requirements. All right, next, let's talk about the benefits of cloud security. So here's something that surprises a lot of people. The cloud is often more secure than on-premises environments. Now, why is this? Well, first, AWS operates at a massive scale. That means continuous monitoring, dedicated security teams, and advanced threat detection. And secondly, AWS offers built-in security features like encryption, identity management, and network isolation. So let's go ahead and talk about encryption specifically because this is a big exam topic. All right, so encryption, this is one of the biggest benefits of cloud security. In AWS, you're going to hear two main terms. The first is encryption at rest. And this basically protects data when it is stored, like in a database or some storage service. And you got examples like Amazon S3 encryption and Amazon EBS encryption. And then there's encryption in transit, and this protects data while it's moving across networks. We're talking about things like HTTPS and TLS connections. And also, AWS provides centralized key management through services like AWS Key Management Service, allowing you to control encryption keys. So in real-world IT roles, encryption is non-negotiable. So whether you're securing customer data or internal systems, encryption, this is your first line of defense. All right, so let's go ahead and talk about how AWS helps you actively secure your environment. And there are several key services that you need to know for the exam and for the real world. First is threat detection and monitoring. So within that, we have what is called Amazon Guard Duty, and this detects malicious activity using machine learning and threat intelligence. You also have what is called AWS Security Hub, and this is a central dashboard for security alerts and compliance status. You also have what is called vulnerability management, and within that, you have what is called Amazon Inspector, and this scans for EC2 instances and applications for vulnerabilities. And then you have DDoS protection with things like AWS Shield, where this protects against DDoS attacks. And together, these tools, they basically form a layered security approach where they detect, analyze, and respond to threats. All right, next, let's talk about logging and monitoring. So one of the most important skills in cloud security is knowing where to find logs. And when it comes to logs, they are critical because they show who accessed what, help detect suspicious behavior, and they can support audits and compliance. And here are the main services that you need to know. So there's monitoring, such as Amazon CloudWatch, where this tracks metrics, logs, and alarms in real time. You have auditing, such as AWS CloudTrail, where this records all API calls made in your AWS account. You have AWS Config, where this can track changes to resources over time. And you also have what is called AWS Audit Manager, where this helps automate compliance audits. So in real world scenarios, if something goes wrong, like a data breach, then these tools are your forensic evidence. All right, next we have policies, controls, and reporting. So governance, this isn't just about setting rules, it's about enforcing them. And AWS provides several ways to do this. You have identity and access management policies, you have resource tagging, and you have service control policies. And for reporting, AWS provides access reports, compliance dashboards, and audit logs. And all of this allows organizations to track user activity, ensure policies are being followed, and generate reports for auditors. Now, understand that not all AWS services are created equal when it comes to compliance. So for example, some services are HIPAA eligible while others are not, and some support encryption by default where others require configuration. And this means that you must always check service compliance documentation, verify eligibility for your use case, and ensure proper configuration. And this is a key exam concept because compliance, this depends upon how you use the service, not just the service itself. All right, so let's go ahead and put all this wonderful information together. So let's say that you're working for a healthcare company moving to AWS. Here's what you might do. You're going to use AWS Artifact to verify HIPAA compliance. You're going to store data in a compliant region. You're going to encrypt your data at rest and in transit. You're going to use Guard Duty for threat detection. You're going to monitor your logs with CloudTrail and CloudWatch. And you're going to use AWS Config to ensure configurations stay compliant. And if you do all of that, well, that is a full security, governance, and compliance workflow, which is exactly what AWS wants you to understand for this exam. But here's the reality. Security is not optional in IT anymore. So whether you're going into help desk, system administration, cloud engineering, or cybersecurity, you're going to deal with these concepts. Understanding AWS security, governance, and compliance, this gives you a strong foundation in cloud security, real-world skills employers are looking for, and a major advantage in certification exams. And honestly, once you understand these concepts, you're going to start to see cloud environments differently because you won't just see servers and storage. You're going to see policies, controls, risk, and protections working together. And that's the mindset shift that takes you from beginner to professional. Now, with all that being said, let's do some check on learning. So our first question is, which AWS service provides a centralized location to access compliance reports and agreements such as SOC reports and ISO certifications? Would this be AWS Artifact, AWS CloudTrail, Amazon CloudWatch, or AWS Config? And the correct answer is AWS Artifact. So AWS Artifact, this is the service specifically designed to provide on-demand access to AWS compliance documentation and agreements. And this includes reports like SOC 1, 2, and 3, ISO certifications, and PCI DSS documentation. Next question, which of the following best describes encryption in transit in AWS? Is it protecting data stored on disk using encryption keys? Is it protecting data while it is being transferred between systems? Is it backing up data to multiple geographic locations? Or is it restricting access using IAM policies? And the correct answer is protecting data while it is being transferred between systems. So encryption in transit ensures that data is secure while moving across the network, typically using protocols like HTTPS or TLS. And our final question is, a company wants to detect suspicious activity and potential threats in their AWS environment using machine learning and threat intelligence. Which AWS service should they use? Would this be AWS Shield, AWS Config, AWS Audit Manager, or Amazon Guard Duty? And the correct answer is Amazon Guard Duty. So Amazon Guard Duty, this is a threat detection service that continuously monitors AWS accounts for malicious or unauthorized activity using machine learning and threat intelligence. All right, so when people first get into AWS, they usually get excited about spinning up EC2 instances, building S3 buckets, or deploying applications. But here's the truth that experienced professionals know. If you do not understand access management, then you do not really understand AWS. So access management, this determines who can do what, when, and how inside your cloud environment. It's the gatekeeper, it's the security guard, and it's the difference between a secure system and a breached one. And in AWS, this is handled primarily through identity and access management and related services. So with all that being said, let's go ahead and get into this lesson. All right, so first things first, what is AWS Identity and Access Management? Well, at its core, this is the service that allows you to control access to AWS resources. So think of it like this. You got your users, those are your individual people or your services. You got your groups, these are collections of users. You got your roles, these are temporary access permissions. And you have your policies, these are the rules that define the permissions. So instead of giving everyone full access, which would be a disaster, identity and access management, this allows you to precisely control permissions. So for example, a help desk technician, they might only have access to reset passwords. A developer, they might only be able to deploy applications, but they cannot delete databases. And a security analyst, they might only view logs. That's identity and access management in action. All right, now let's talk about the root user and why AWS makes such a big deal about it. So when you first create an AWS account, you automatically get the root user. And this account has unrestricted access to everything. And this includes closing the account, changing billing settings, accessing all services and data, and modifying permissions. And because of this, the root account is extremely powerful and extremely dangerous. So as a best practice when it comes to the root user, do not use the root account for daily work, as in never use it. Instead, create a user account for yourself, assign it admin permissions, and then lock the root account right away. All right, next, let's talk about how do you protect the root account. So protecting the root account, this is one of the most important concepts for both the exam and real world security. So here's what you should always do. You want to enable multi-factor authentication because this adds a second layer of security beyond just a password. You obviously want to use a strong password, so don't go out there and create password 123. Instead, use a long and complex password. Do not create access keys for the root because access keys, they can allow programmatic access, and you should never create these for the root user. You want to store your credentials securely, so use tools like AWS Secrets Manager or AWS Systems Manager Parameter Store. Also, you only want to use the root for specific tasks. And there are certain tasks that only the root user can perform, like changing support plans, closing the account, and recovering permissions issues. So if you see a question on the exam asking you something like which account should perform X critical task, then the answer is more than likely the root user. All right, next, let's talk about the principle of least privilege. And this is one of the most important security concepts, not just in AWS, but in IT overall. And the principle states the following: only give users the permissions they need and nothing more. Now, why is that? Because if an account gets compromised, then the damage is limited. So an example of this could be you giving somebody full admin access. That's obviously a bad thing. Instead, you only want to give the user access to read operations or whatever the heck it is that they need to do so that they can fulfill the requirements of their job. And why do you do this? Because this reduces accidental mistakes, it reduces insider threats, and hopefully it reduces security breaches. All right, next, let's talk about identity and access management, users, groups, and roles, which are your core building blocks. So when it comes to the users, they represent individual people or applications, and they have long-term credentials like a username and password or some type of access key. Then you have groups, and these are collections of users. They are used to assign permissions at scale. So an example of this would be the developers group, where they have access to EC2 plus S3. And then you have the HR group, where they would only have access to specific data only. And then you have roles, and these are used for temporary access. These are commonly used for applications, cross-account access, and federated users. So just understand that roles, they are huge in real-world AWS environments and in IT in general. All right, next let's talk about access keys, passwords, and credential storage. So when users or applications interact with AWS, they need credentials, and there are two main types. The first one is a password, and this is used for logging into the AWS Management Console. And then you have your access keys, and these are used for your CLI or your command line interface and your SDKs for applications. And also access keys, they consist of an access key ID and a secret access key, and all of that must be protected at all costs. All right, next let's talk about how you should never hard code credentials. So one of the biggest mistakes that beginners make is putting credentials directly into code. So instead of doing that, you want to use stuff like AWS Secrets Manager, where this can store sensitive data like passwords and API keys, and it can automatically rotate credentials. And then you also have this thing called AWS Systems Manager Parameter Store, where this can store configuration data securely. And this is often used for application settings. All right, so moving on, let's talk about authentication in AWS, and this is where users prove who they are. So AWS supports several authentication methods. Obviously, we have the username and password, and this is your basic login for identity and access management. You got multi-factor authentication, where this adds an extra layer like a phone or a token. You got the IAM Identity Center, and this is used for SSO or single sign-on. And this basically allows you to log in once and access multiple AWS accounts. Do you have what is called cross-account roles, where this allows users from one account to access another securely. All right, next let's talk about the AWS Identity Center for single sign-on. Now, this used to be called AWS SSO, and it is a big focus area because this allows organizations to manage access across multiple AWS accounts, where you can use one login for everything, and it is integrated with external identity providers. So an example of this would be a company that uses Microsoft Entra ID, where an employee can log in once and then they can access multiple AWS accounts. And basically, this is essential in enterprise environments. All right, moving on, we have what are called federated identities. So instead of creating identity and access management users, you can use federation. And basically, this means that users, they can authenticate through an external system. And obviously, for that to happen, AWS has to trust that system. So an example could be like your Google login or your corporate Active Directory account. And the benefits are it provides centralized identity management, reduced credential sprawl, and it has an easier user lifecycle management. And then we have our identity and access management policies. So understand that policies are JSON documents that define permissions, and they basically answer what can the user actually do. There were two main types. The first one is called a managed policy, and this is created and maintained by AWS or your organization, and it is reusable. Then you have your custom or inline policies, and these are created for specific users or roles, and they are typically more granular. All right, so why does any of this stuff even matter? Well, if you take nothing else from this lesson, just remember this. Access management, this is the backbone of AWS security. Everything you build, from applications to storage to networking, all of that depends on it being secure. For the exam, you're going to have to expect to get questions about identity and access management, multi-factor authentication, least privilege, and root user protection. So when it comes to real life application, if you understand all of this information, this is what's going to separate you from everybody who thinks they know something and put you in the category of those who actually know something. So with that being said, let's do some check on learning. So our first question is, a company wants to ensure that its employees can only access the AWS resources necessary to perform their job functions and nothing more. Which AWS security principle does this represent? Is this the shared responsibility model? Is this multi-factor authentication? Is this defense in depth? Or is this the principle of least privilege? And of course, the answer is going to be the principle of least privilege. So basically, this means granting users only the permissions they need to perform their specific task and nothing more. And this helps minimize the risk of accidental changes, insider threats, and security breaches. Next question. Which of the following is a recommended best practice for securing the AWS root user account? Is it use the root account for daily admin tasks? Is it share root credentials with team members for convenience? Is it enable multi-factor authentication on the root account? Or is it create access keys for the root user for programmatic access? And the correct answer is you want to enable multi-factor authentication on the root account. So enabling MFA on the root account, this is one of the most critical security steps in AWS, and best practices include enabling MFA, using a strong password, avoiding daily use, and not creating access keys. And our final question is, a company wants to allow users to log in once and accept multiple AWS accounts using a centralized identity provider such as Microsoft Entra ID or Okta. Which AWS service should they use? Should they use AWS IAM roles, AWS IAM Identity Center, AWS Secrets Manager, or AWS Organizations? And the correct answer is AWS IAM Identity Center. So AWS IAM Identity Center, this enables centralized access management, SSO across multiple AWS accounts, and integration with external identity providers. All right, so when people first get into cloud computing, one of the biggest concerns they have is security. And honestly, that's a good thing, because in traditional IT environments, security was something you physically controlled, meaning you had to lock your server rooms, you had to have badge access, and you had that firewall sitting in your rack. But in the cloud, you don't see the hardware and you don't touch the servers. So naturally, the question becomes, how secure is all this stuff really? Well, here's the truth. AWS operates on what's called a shared responsibility model. That means AWS handles the security of the cloud, such as the data centers, the physical hardware, and the global infrastructure, while you are responsible for security in the cloud. We're talking about your data, your configurations, your permissions, and your applications. And once you understand that distinction, then everything else starts to make sense. So with that being said, let's go. All right, so let's start with the big picture. AWS, this provides a massive set of built-in security capabilities that are designed to help organizations protect their data, applications, and infrastructure. And these aren't optional add-ons. They are foundational pieces of the platform. And one of the core services you'll hear about immediately is AWS Identity and Access Management. And you could think of this as the gatekeeper of your AWS environment. It controls who can access what. You can create users, groups, and roles, and define permissions using policies. So for example, you can allow a developer to access EC2 instances, but restrict access to billing information. And this is where the principle of least privilege comes into play, where it only gives users the exact permissions they need and nothing more. Now, another major capability is encryption. And AWS allows you to encrypt data both at rest and in transit. And services like AWS Key Management Service, this can help you create and manage cryptographic keys. So whether you're storing files in S3 or running databases in RDS, encryption is often just a checkbox away, but understanding why and when to use it is what separates beginners from professionals. And then there's monitoring and logging. So AWS provides tools like Amazon Cloud Watch and AWS Cloud Trail to track activity and performance. In Cloud Trail, this logs every API call made in your account, which is incredibly useful for auditing and detecting suspicious behavior, because if someone tries to access resources that they shouldn't, well, you will have a record of it. All right, so now let's talk about one of the most exam-tested areas, and that is network security. So in AWS, you don't just spin up resources and hope for the best. You control traffic flow at multiple layers. And the first layer is security groups. So think of them as virtual firewalls attached to your resources, like EC2 instances. They control inbound and outbound traffic. So for example, you can allow HTTP traffic on port 80 from anywhere, but restrict SSH access on port 22 to your IP address only. And security groups, they are stateful, meaning if you allow inbound traffic, then the response is automatically allowed. And then you have what are called network access control lists, or ACLs, which operate at the subnet level. And these are stateless, meaning you must explicitly allow both inbound and outbound traffic. And basically, they provide an additional layer of control, acting as a backup to security groups. And then there's the AWS Web Application Firewall. And this is designed to protect your web applications from common threats like SQL injection and cross-site scripting. So if you're running a public-facing application, then the Web Application Firewall, this is a powerful tool to filter out malicious traffic before it even reaches your servers. Now together, these tools, they create a layered security approach, which is often referred to as defense in depth, because if one layer fails, then another is there to catch the threat. All right, so let's move on and talk about AWS services for identifying security issues. So understand that security isn't just about prevention, it's also about detection. You need to know when something goes wrong. In AWS, it provides several services to help you out with that. And one of the most important is AWS Trusted Advisor. And Trusted Advisor basically acts like a built-in consultant for your AWS account. It analyzes your environment and provides recommendations across multiple categories, including security. So for example, it might warn you if you open security groups exposing your resources to the internet, or if you're not using multi-factor authentication on your root account. Another key service is Amazon Guard Duty. And Guard Duty continuously monitors your environment for suspicious activity using machine learning and threat intelligence. And it can detect things like unusual API calls, compromised instances, or communication with known malicious IP addresses. Then there's also AWS Security Hub, which aggregates security findings from multiple services into a single dashboard. And this makes it easier to see the overall security posture of your environment without jumping between different tools. And these services are essential for maintaining visibility and ensuring that your environment remains secure over time, not just as deployment. All right, next let's talk about AWS security documentation and learning resources. So if you're preparing for this exam, then you need to know where to find reliable information. In AWS, it provides a ton of documentation and resources, and knowing where to look is actually part of the exam objective. So one of the most valuable resources is the AWS Knowledge Center. This is essentially a collection of FAQs and troubleshooting guides. So if you run into an issue, then chances are someone else has already asked the same question, and AWS has documented the solution. Another key resource is the AWS Security Center. And this is your go-to hub for everything related to AWS security, including compliance programs, white papers, and best practices. So if you want to understand how AWS meets regulatory requirements like HIPAA or GDPR, then this is where you go. And don't overlook the AWS Security blog. This blog regularly publishes updates, case studies, and deep dives into security topics. And it's a great way to stay current with new threats and solutions. So the key takeaway here is this: AWS does not just give you the tools, they also give you the knowledge to use them effectively. And then let's talk about some third-party security solutions in the AWS marketplace. Now, while AWS provides a robust set of native security tools, some organizations need specialized solutions, and that's where the AWS marketplace comes in. So the AWS marketplace, this basically allows you to browse, purchase, and deploy third-party software directly into your AWS environment. And this includes security tools like firewalls, intrusion detection systems, vulnerability scanners, and compliance monitoring solutions. So for example, companies like Palo Alto Networks and Fortinet and Trend Micro, they offer advanced security products that integrate seamlessly with AWS. And these tools can provide additional layers of protection, especially for organizations with complex or highly regulated environments. Now, the important thing to understand for the exam is this: that AWS security is not limited to AWS native services. You do have the flexibility to extend your security architecture using third-party solutions when they are needed. All right, so why does all of this stuff even matter? Well, let's bring this back to reality for a moment. So imagine that you're working as an entry-level cloud support technician or a junior cloud engineer, and your company is migrating applications to AWS, and suddenly you're responsible for ensuring those applications are secure. So you might be asked to configure the identity and access management roles for a new application. You might be asked to lock down security groups to prevent unauthorized access. You might have to enable logging with CloudTrail for auditing purposes. You may have to review trusted advisor recommendations for potential risks, and you may have to deploy a web application firewall to protect a public-facing website. Now, these aren't theoretical tasks. These are actual real-world responsibilities, and the concepts you're learning for this exam directly maps to those tasks. So if there's one thing that you should walk away with, it is this: AWS is not a single tool or service. It is an ecosystem. It is a combination of identity management, network controls, encryption, monitoring, detection, and continuous improvement. Because AWS is going to give you tools like identity access management and guard duty. They're going to give you the insights like Trusted Advisor and the Security Hub. Also, they're going to give you the documentation like the Knowledge Center and the Security Blog. And they're going to give you the flexibility of using third-party tools via the marketplace. But ultimately, it is up to you to use them correctly. And that's exactly what this exam is testing. They're not testing whether you can configure configure every setting, but whether you understand what tools exist, what they do, and when to use them. So just understand that security in the cloud can feel overwhelming at first, but once you break it down, it can become manageable. So start with identity and access, then add your network controls, layer in monitoring and detection, and use your documentation to guide you. And do not be afraid to leverage third-party tools when necessary. So if you can explain how IAM controls access, how security groups and network ACLs protect resources, and how web application firewalls defend web apps, and how your trusted advisor identifies risk and where to find AWS security information, then you're not just ready for the exam, you're already thinking like a cloud professional. And in today's world, that's a skill set that's in serious demand. All right, so with all that being said, let's do some check on learning. So our first question is, which AWS service is primarily used to control who can access AWS resources and what actions they can perform? Is it AWS Identity and Access Management, Amazon CloudWatch, AWS WAF, or AWS Trusted Advisor? And the correct answer is AWS Identity and Access Management. So this is the core service used for managing authentication, such as who you are, and authorization in terms of what you can do in AWS. It allows you to create users, groups, and roles and assign permissions using policies. CloudWatch, this monitors performance. The Web Application Firewall, this protects web applications. And Trusted Advisor, this provides recommendations, but none of them directly control access like Identity Access Management. Next question. Which AWS security feature is designed to protect web applications from common attacks like SQL injection and cross-site scripting? Is it AWS WAF, AWS Key Management Service, Amazon Guard Duty, or AWS CloudTrail? And the correct answer is AWS WAF, or your web application firewall. And this filters and monitors HTTP and HTTPS requests to protect web applications from common vulnerabilities like SQL injection and cross-site scripting. KMS, this handles encryption. Guard Duty, it detects threats. And CloudTrail, this logs API activity. But the web application firewall is specifically designed for web application protection. And our final question is, where can you find official AWS security best practices, white papers, and compliance information? Would this be the AWS Marketplace, the Security Center, Amazon Guard Duty, or the Trusted Advisor? And the correct answer is the AWS Security Center. So this is the central hub for security-related documentation, including white papers, compliance programs, and best practices. AWS Marketplace, this is for third-party tools, and Guard Duty is for threat detection. And Trusted Advisor, this provides recommendations, not documentation. All right, so when most people first hear about the cloud, they think it's just about spinning up servers and storing files somewhere, quote unquote, out there. But if you're preparing for the AWS exam, or honestly just trying to build real world cloud skills, then you're going to quickly realize something important. And that is, knowing what AWS services do is only half the battle. The real game is understanding how you deploy, access, and operate those services in different environments. And this is where this exam objective comes in, and it's one of the most practical sections you'll learn, because in real life, companies don't just click buttons randomly in AWS. They carefully choose how to deploy resources, how to connect them, and how to manage everything efficiently and securely. So with that being said, let's go. All right, so let's start with the foundation, and we're talking about provisioning resources. And this simply means creating and configuring AWS services, like launching a virtual machine, setting up storage, or building a network. In AWS, there are several ways to do this, and each one fits a different type of workflow. And the most beginner-friendly method is using the AWS Management Console. And this is the web-based interface where you log in, click around, and visually configure your resources. So if you've ever created an EC2 instance by clicking through a wizard, then you're already used to it. It's intuitive, visual, and perfect for learning or doing quick one-off tasks. But here's the thing. While the console is great for getting started, it does not scale well. So imagine managing hundreds of servers manually through a web interface. Well, that's not just inefficient, it can be a nightmare waiting to happen. And that's where more advanced methods come in, like the AWS command line interface and software development kits. These allow you to interact with AWS programmatically. So instead of clicking buttons, you're running commands or writing code to create and manage resources. So for example, instead of manually launching an EC2 instance, you can run a CLI command that does it instantly. Or better yet, you can write a script that launches 10 instances, configures them, and deploys your applications all in seconds. And this is how real-world environments operate. And then we take it one step further with infrastructure as code. And this is where things get powerful, because with tools like AWS CloudFormation or Terraform, you define your entire infrastructure in code, not just one server, but your entire environment. We're talking about your networks, your databases, security groups, load balancers, essentially everything. And the beauty of infrastructure as code is its repeatability, meaning you can deploy the exact same environment over and over again without mistakes. And this is huge in enterprise environments where consistency matters. All right, now let's talk about how you actually access AWS services, because this ties directly into how you operate in the cloud. There are three primary ways. You have AWS Management Console, which is your GUI or your graphical user interface. You got your command line interface, and you have your programmatic interface or APIs and SDKs. Now, the console, this is great for beginners, demos, and quick troubleshooting because it gives you visibility and control in a user-friendly way, but it is not ideal for automation. The CLI, this is where things start to get more efficient because it allows you to execute commands quickly, script operations, and integrate with automation workflows. So if you're working in IT, cybersecurity, or DevOps, this is a must-learn tool. And then you have programmatic access using APIs and SDKs, and this is how developers interact with AWS inside applications. So for example, an app might automatically upload files to S3 or spin up resources based on user demand, and all of that is happening through APIs behind the scenes. So how do you decide which one to use? Well, it all comes down to your use case. So if you're doing a one-time setup or learning, then the console is fine. If you're managing systems on the regular, then the CLI is better. And if you're building scalable applications, then programmatic access is the way to go. All right, next, let's talk about one-time operations versus repeatable processes. Now, understand that this is a big concept for both the exam and real-world cloud work. So a one-time operation, this is exactly what it sounds like. You do it once and you're done. Maybe you're testing something, spinning up a temporary server, or configuring a quick lab environment. In these cases, using the console is usually fine. But in production environments, one-time operations are risky. And the reason why is because they're manual. In manual processes, they can lead to mistakes, inconsistencies, and security issues. That's why organizations prioritize repeatable processes. And when it comes to repeatable processes, they use automation. So we're talking scripts, templates, or infrastructure as code. And they do all of that to ensure that everything is deployed the same way every single time. And this improves reliability, reduces human error, and makes scaling much easier. So think about it like this. If your company needs to deploy 50 servers across multiple regions, are you going to click through the console 50 times, or are you going to run a script or deploy a template that does it automatically? Which one makes more sense to you? And this is why infrastructure as a code is such a big deal in AWS, because it turns infrastructure into something you can version, track, and reuse, just like software. All right, now let's zoom out a bit and talk about deployment models, because not every organization is fully in the cloud. And the simplest model is cloud only. And this is where all your infrastructure lives in AWS. Your servers, databases, applications, everything is hosted in the cloud. And this is common for startups and modern applications because it's scalable, flexible, and cost efficient. And then you have on-premises, which is the traditional model where everything is hosted in a physical data center owned and managed by the organization. Now, while this gives you full control, it also comes with higher costs and less flexibility. But the most interesting model is the hybrid model. So hybrid deployments, they combine on-premises infrastructure with cloud services. So for example, a company might keep sensitive data in their local data center, but use AWS for web applications or backup storage. And this approach allows organizations to transition to the cloud gradually while still maintaining control over critical systems. And then there's also a variation called multi-cloud, where companies use multiple cloud providers. But for the exam, your focus should mainly be on cloud, hybrid, and on premises. All right, so let's get into connectivity, because deploying resources is one thing, but connecting them is where the real architecture happens. So in AWS, there are three main ways to connect your environment. And the first one is the public internet. And this is the simplest method. Your resources communicate over the internet using public IP addresses. It's easy to set up and works well for web applications and public facing services, but it's not always ideal for sensitive data or high performance workloads because it relies on a shared infrastructure. And then you have AWS VPN. So a VPN, or a virtual private network, this creates a secure encrypted connection between your on-premises network and AWS. And this is great for hybrid environments where you want to securely connect your internal network to your cloud resources. It's relatively quick to set up and cost effective. However, VPN connections can have limitations in terms of bandwidth and latency. And then there's AWS Direct Connect. And this is where things get serious because AWS Direct Connect just provides a dedicated private connection between your data center and AWS. It doesn't go over the public internet, which means lower latency, high performance, and more consistent network experience. And this is typically used by large enterprises that need reliable, high-speed connectivity for critical workloads. All right, so let's go ahead and put all of this wonderful information together. So now that we've covered provisioning methods, access options, deployment models, and connectivity, how does all of this come together in the real world? So let's say a company is building a new application. First, they decide on a deployment model. Maybe they go with hybrid because they already have an on-premise data center. Next, they choose how to provision resources. So instead of manually creating everything, they use infrastructure as code to define their environment. Then they decide how to access and manage AWS. Developers use SDKs to integrate AWS services into the application, while administrators use a CLI for automation. And finally, they choose a connectivity option. Maybe they start with a VPN for quick setup, and later upgrade to Direct Connect for better performance. And every decision that is made is intentional. And that's exactly what AWS wants you to understand for this exam. Because if there's one thing to take away from this objective, is this: working in AWS isn't just about knowing services. It's about making smart decisions. And you need to understand when to use the console versus automation, when to choose one-time actions versus repeatable processes, and when to deploy fully in the cloud versus using a hybrid model, and how to connect everything securely and efficiently. And this is what separates someone who just knows AWS from someone who can actually work in AWS. And if you think through these decisions logically, not only will you pass this exam, you'll also be building the mindset of a real cloud professional. All right, so with all that being said, let's do some check on learning. So our first question is, a company needs to deploy with the same AWS infrastructure across multiple environments with consistency and minimal human error. Which approach is best suited for this requirement? Is it using the AWS Management Console for each environment? Is it using infrastructure as code with tools like AWS CloudFormation? Is it manually configuring each resource using the AWS CLI? Or is it using a VPN connection to replicate environments? And the correct answer is using infrastructure as code with tools like AWS CloudFormation. So infrastructure as code, this allows you to define your entire environment in code, making it repeatable, consistent, and automated. And this is exactly what organizations need when deploying across multiple environments. Next question. A developer is building an application that needs to automatically upload files to Amazon S3 whenever a user submits data. Which method of accessing AWS services is most appropriate? Is it AWS Management Console, AWS Direct Connect, AWS SDK, or AWS VPN? And the correct answer is AWS SDK. So programmatic access using APIs or SDKs. This allows applications to interact with AWS services automatically. And this is essential for building scalable dynamic applications. And our final question is, an organization wants a private, high-speed, and low-latency connection between its on-premises data center and AWS. Which connectivity option should they choose? Should it be the public internet, AWS VPN, AWS Direct Connect, or AWS Management Console? And the correct answer is AWS Direct Connect. So Direct Connect, this provides a dedicated private connection between your on-premises environment and AWS, offering lower latency, higher bandwidth, and more consistent performance. All right, so if you're preparing for the AWS Cloud Practitioner exam, then one of the most important concepts to truly understand and not just memorize is AWS Global Infrastructure. This isn't just a bunch of data centers scattered around the world. It is a carefully designed system built for performance, resilience, scalability, and global reach. Now, at its core, AWS Global Infrastructure is how AWS delivers cloud services to millions of customers worldwide. So think of it like a massive interconnected network of locations that ensures your applications run fast, stay online, and can recover from failures. Now, instead of thinking about the cloud as something vague, picture it as a physical and logical network made up of regions, availability zones, edge locations, local zones, and what are called wavelength zones. Each plays a specific role, and understanding how they work together is exactly what this objective is testing. So with that being said, let's go. All right, so let's start with AWS regions. Now, an AWS region, this is a geographic area that contains multiple data centers. And some examples include the US East out in North Virginia. You got the US West out in Oregon. You got places in Europe like Ireland that host some data centers, and places out in Asia Pacific like Tokyo. Now, each region is completely independent of the others, and that means they have their own separate power, separate networking, and separate fault domains. And this independence is critical because if something catastrophic happens in one region, like a natural disaster or some type of major outage, then your application can still run in another. So exactly why do regions even matter? Well, regions, they are the foundation for data sovereignty, which means keeping data in a specific country. They also have compliance requirements. They have latency optimization, meaning they're closer to users, which equals a faster response. And they have disaster recovery strategies. So for example, if you're running a global application, you might deploy both for North American users and for those in the European Union. And this reduces latency and it improves user experience. All right, next let's talk about availability zones. So inside each region, you're going to find multiple availability zones. And an availability zone, this is one or more data centers with independent power, cooling, and networking. So here's the key idea. Availability zones, they are basically isolated from each other, but they are connected. This means they can communicate with low latency, but they do not share single points of failure. Now, why is this so important? Well, let's say your application is running in one availability zone and that AZ goes down. If you only deploy it there, then your application is down. But if you deploy it across multiple AZs, then AWS can automatically fail over, keep your application running, and maintain uptime. And this is what AWS calls high availability. Now, exactly how would you use AZs? Well, in practice, you might run web servers in AZ1 and AZ2. You might use a load balancer to distribute the traffic, and then you might store data redundancy across the AZs. And if you do all of that, then guess what? You will have a resilient architecture. All right, next let's talk about the relationship between a region, an availability zone, and the edge. So a region, this is a geographic area. Availability zones, these are isolated data centers inside that region. And edge locations, these are locations closer to users for faster delivery. So think of it like this. A region, this is your city. An availability zone, this is the buildings that are in that city. And the edge, these are the delivery trucks that are already near your customers. So just keep that model in mind because hopefully that will help you answer a lot of questions when it's time for you to take this test. All right, next, let's talk about edge locations. And this is where performance gets interesting. So edge locations, these are used by services like Amazon CloudFront and AWS Global Accelerator. And these locations are closer to end users than regions. So what do they actually do? Well, they cache content like images, videos, or web pages, so users do not have to reach all the way back to a region. Instead of the user going all the way back to the region, which is very far away, the user would just simply go to the edge location where that data is available, which is, obviously closer than the region. And so what are the benefits of edge locations? Well, they offer lower latency, which translates into faster load times. They improve the user experience and they reduce load on the original servers. And this is especially important for streaming platforms, global websites, and gaming applications. All right, next, let's talk about high availability. And this is one of the biggest reasons companies move to AWS. So at a high level, this means that your system stays operational even when parts of it fail. And how does AWS achieve high availability? Well, they use multiple AZs in a region. So if one AZ fails, the others keep running. They have a redundant infrastructure consisting of power, cooling, and networking. They offer load balancing where the traffic is distributed automatically. And they have failover mechanisms where the systems switch to healthy resources. So a key exam concept you need to understand is this: availability zones, they do not share single points of failure. Now, that is a big one. So if you remember nothing else, you need to remember that. All right, next let's talk about when to use multiple regions. So using multiple availability zones, this protects you from localized failures. And using multiple regions, this protects you from regional disasters. So when would you do this? Well, you would use multiple regions for disaster recovery. In the event an entire region goes down, another one will just simply take over. You would use it for business continuity, so your applications will keep running no matter what. You would use it for low latency, and this serves users with the closest region. And you would also use it for data sovereignty, where you keep data in specific countries for legal reasons. So an example scenario will be something like this: a global e-commerce company that might run the primary infrastructure in the US East, replicate the data to Europe, and then fail over if needed. And that is called enterprise level resilience. All right, next we have what are called AWS local zones. So sometimes even a region is not close enough, and that's where local zones come in. And AWS local zones, they basically extend AWS infrastructure into major cities to be closer to the users. Now, why would you use a local zone? Well, they support ultra low latency applications. They provide real-time processing, media production, and they support gaming. So instead of sending traffic to a distant region, local zones, they bring the compute resources near the user. And then we have what are called AWS wavelength zones. So now we're getting into the cutting edge stuff here. So AWS wavelength, this integrates AWS services directly into 5G networks. So what does that mean? Well, it allows applications to run with ultra low latency. We're talking about running stuff in milliseconds, and it provides direct connection to mobile devices. In the use cases, you'll find it's being used in autonomous vehicles, augmented reality, virtual reality applications, real-time gaming, and you'll find it in smart cities. So basically, this is where cloud meets telecom infrastructure. All right, so let's go ahead and wrap all this up. So by now, you should see how everything connects. You have regions, they provide global coverage. Availability zones, they provide high availability. Edge locations provide speed. Local zones provide ultra low latency in cities. And wavelength zones, they provide ultra low latency via 5G. And this layered approach is what makes AWS so powerful. Now, if you're studying for the AWS exam, here's what AWS really wants you to understand. First, you do not just deploy in one place, you design for resilience. Once again, high availability, this equals multiple availability zones. Disaster recovery, this equals multiple regions. Performance, this equals edge locations. And latency sensitive applications, this equals local zones or wavelength. And most importantly, AWS is built so that failure is expected and handled automatically. That mindset shift from preventing failure to designing through failure, this is what separates beginners from real cloud professionals. All right, so with all that being said, let's do some check on learning. So our first question is, which statement best describes an AWS availability zone? Is it a global content delivery location used to cache data near users? Is it a collection of regions connected by high-speed networking? Is it a backup system used only for disaster recovery across regions? Or is it one or more data centers with independent power, cooling, and networking within a region? And the correct answer is it is one or more data centers with independent power, cooling, and networking within a region. So an AZ is made up of one or more data centers that are physically separated but located within the same AWS region. Each AZ has independent infrastructure, including power, cooling, and networking. And this design ensures that AZs do not share single points of failure, which is critical for building highly available systems. Next question. A company wants to ensure its web applications remain available even if one data center fails. What is the best solution? Is it to deploy the application in a single availability zone with backups? Is it to deploy the application across multiple availability zones within the same region? Is it to deploy the application in a single region only? Or is it to use edge locations without using availability zones? And the correct answer is it is to deploy the application across multiple availability zones within the same region. So to achieve high availability, AWS recommends deploying applications across multiple AZs within the same region, and this allows traffic to be automatically rerouted if one AZ fails, ensuring minimal downtime. And our final question is, which scenario best justifies using multiple AWS regions? Is it reducing latency for users within a single city? Is it improving performance using cache content? Is it ensuring business continuity and disaster recovery in case an entire region fails? Or is it increasing storage capacity within one availability zone? And the correct answer is it is ensuring business continuity and disaster recovery in case an entire region fails. So using multiple AWS regions is primarily about disaster recovery and business continuity. So if an entire region becomes unavailable, then your application can fail over to another region, keeping services running. All right, so if you're preparing for the AWS exam, then one of the most important topics you'll encounter is compute services. So think of compute as the engine of the cloud because it's actually what runs your applications, processes your data, and powers everything from simple websites to massive enterprise systems. In the AWS world, compute isn't just one thing, it's a collection of flexible services that let you choose how your applications run, where they run, and how much control you want over the infrastructure. And AWS gives you multiple ways to run workloads, ranging from full control over virtual machines to completely serverless environments where you don't manage anything at all. And understanding when to use each option is exactly what AWS expects you to know for the exam. But more importantly, it's what makes you effective in real-world IT roles. So with that being said, let's get into this lesson. All right, so let's talk about the core of AWS compute. So at a high level, compute services, they answer one simple question: where is my code running? In traditional IT environments, that answer was usually a physical server sitting in a data center. In AWS, you have options, a lot of them. You can run virtual machines, containers, or serverless functions, all depending upon your needs. And the main compute services that you need to understand for the exam include the following. We got Amazon EC2, AWS Lambda, Amazon ECS, Amazon EKS, AWS Fargate, elastic load balancing, and auto scaling. And each of these services represents a different level of control, flexibility, and management responsibility. And the key to mastering this objective is understanding when to use each one. All right, so let's start with the most traditional option, and that is Amazon EC2. And EC2, this stands for Elastic Compute Cloud, and it essentially gives you virtual machines in the cloud. So if you ever work with physical servers or even virtual machines like VMware or VirtualBox, the EC2 will feel very familiar. And with EC2, you choose the operating system, you configure the CPU, the memory, storage, and networking, and you're responsible for managing everything inside the instance. And this includes patching, update, security configurations, and application deployment. So in other words, EC2, it gives you maximum control. Now, where EC2 gets really interesting and really important for the exam is in its instance types. So AWS doesn't just give you one kind of virtual machine. Instead, it offers different categories optimized for specific workloads. So for example, compute optimized instances are designed for CPU intensive tasks. So think about things like gaming servers, scientific modeling, or high performance web servers. So if your application needs a lot of processing power, then this is your go-to option. And then there's memory optimized instances, which are built for workloads that require large amounts of RAM. And these are perfect for databases, real-time analytics, and caching systems. So if your bottleneck is memory instead of CPU, then this is what you would choose. And then you have storage optimized instances, which are designed for high disk throughput and large data sets. And these are ideal for big data applications, data warehousing, or log processing systems. Now, the key takeaway here is this, and this is something that AWS loves to test, is that you should match the instance type to the workload. Do not just pick any EC2 instance. Think about what your application actually needs. All right, now let's shift gears and talk about containers. And containers have become a huge part of modern IT, especially with tools like Docker. So instead of running full virtual machines, containers allow you to package applications and their dependencies into lightweight portable units. And AWS offers two main services for managing containers. You have Amazon ECS and Amazon EKS. So Amazon ECS, which stands for Elastic Container Service. This is AWS's native container orchestration platform, and it's relatively simple to use and tightly integrated with other AWS services. So if you're running containerized applications and you want something straightforward without a steep learning curve, then ECS is a great choice. And then you have Amazon EKS, and that stands for Elastic Kubernetes Service. And this is for running Kubernetes. And Kubernetes, this is an open source container orchestration platform that's widely used across the industry. So if your organization already uses Kubernetes or needs advanced container orchestration features, the EKS is the way to go. So exactly how do you choose between ECS and EKS? Well, it really comes down to complexity and familiarity. So ECS is easier to get started with and is ideal for AWS centric environments. EKS is more complex, but it offers greater flexibility and portability, especially if you're working in multi-cloud or hybrid environments. Now for the exam, just remember this simple distinction. ECS, this is AWS native and it is simpler, while EKS is Kubernetes based and more powerful. All right, so let's talk about one of the most exciting parts of the AWS, and that is serverless computing. And this is where things get really interesting because you no longer have to manage servers at all. And the two key services here are AWS Lambda and AWS Fargate. So AWS Lambda, this allows you to run code in response to events without provisioning or managing servers. So basically, you simply upload your code, define a trigger like an HTTP request or a file upload, and AWS handles everything else. It automatically scales, manages infrastructure, and charges you only for the compute time that you use. And Lambda, this is perfect for event-driven workloads. So for example, processing images uploaded to an S3 bucket, running backend APIs, or automating tasks. Now, if your application doesn't need to run continuously and can respond to events, then Lambda is a great fit. And then there's AWS Fargate, which takes a similar approach, but for containers. So instead of managing EC2 instances to run your containers, Fargate lets you run containers without worrying about the underlying infrastructure, meaning you define your container, specify the resources it needs, and AWS handles the rest. Now, the key difference is this. Lambda is for functions. We're talking about small pieces of code triggered by events, while Fargate is for containers. And this is for larger, more complex applications packaged into containers. All right, so let's move on and talk about auto scaling. So one of the biggest advantages of cloud computing is elasticity, and that is the ability to scale resources up or down based on demand. And this is where auto scaling comes into play. So auto scaling, this automatically adjusts the number of compute resources based on traffic or workload. So for example, if your website suddenly gets a surge in traffic, then auto scaling can launch additional EC2 instances to handle the load. And when traffic decreases, it can terminate those instances to save costs. And this is incredibly important for both performance and cost efficiency. So instead of over provisioning resources just in case you need them, you can dynamically adjust based on actual demand. Now for the exam, just remember that auto scaling, this provides elasticity, which is one of the core benefits of cloud computing. All right, next let's talk about load balancing. So imagine that you have multiple servers running your application. Well, how do you ensure that traffic is distributed evenly across them? Well, this is where elastic load balancing comes in. So load balancers, they basically act as traffic managers. They receive incoming requests and distribute them across multiple targets, such as EC2 instances or containers. And this improves availability, fault tolerance, and performance. Now, AWS offers different types of load balancers, but for the Cloud Practitioner exam, you mainly need to understand their purpose rather than their deep technical differences. So the key idea here is simple. Load balancers, they prevent any single server from becoming overwhelmed. They ensure your application remains available even if some instances fail. All right, so at this point, you might be wondering how all of these services fit together, and the real skill and what AWS wants you to demonstrate is the ability to choose the right service for the job. So if you need full control over the operating system and environment, then EC2 is your best option. If you're working with containerized applications and want orchestration, then you're going to choose ECS or EKS. And if you want to avoid managing servers entirely, then you're going to go with Lambda or Fargate. Now, understand that this is all about trade-offs. So just understand that more control usually means more responsibility, while less control means more convenience. All right, so let's bring things into the real world. So imagine you're building a simple web application. You might start with EC2 instances behind a load balancer using auto scaling to handle traffic spikes. Now, as your application grows, you might containerize it and move to ECS or EKS for better scalability and deployment flexibility. Now, if parts of your application can be event driven, like processing uploads or sending notifications, then you might use Lambda for those components. And over time, you might even adopt a fully serverless architecture. And this layered approach is very common in modern cloud environments, and understanding how these services work together. This is what separates someone who just memorizes definitions from someone who truly understands AWS. All right, so let's go ahead and wrap all this up. So as you prepare for the AWS Cloud Practitioner exam, remember that this objective isn't just about memorizing service names. It's about understanding concepts. We're talking about control versus convenience, scalability, cost efficiency, and workload optimization. Now, if you can confidently answer questions like, when should I use EC2 versus Lambda, or what type of instance is best for this workload, then you're on the right track. And honestly, this knowledge goes far beyond the exam. These are the same decisions that you're going to make in real IT roles, whether you're deploying applications, designing architectures, or troubleshooting performance issues. So take your time with this topic, think through real world scenarios, and make sure you truly understand how these services fit together. Because once you do, then AWS Compute will stop feeling complicated and start feeling like a powerful toolkit that you can actually use. Now, with all that being said, let's do some check on learning. Our first question is, a company is running a high performance application that requires intense CPU processing for tasks like video encoding and scientific calculations. Which Amazon EC2 instance type is most appropriate? Is this compute optimized, memory optimized, storage optimized, or general purpose? And the correct answer is compute optimized. So compute optimized instances are specifically designed for workloads that require high CPU performance. And this includes tasks like video encoding, gaming servers, and scientific modeling. Next question. A developer wants to run code in response to events such as file uploads or API calls without managing any servers. Which AWS service should they use? Would this be Amazon EC2, Amazon ECS, AWS Lambda, or Amazon EKS? And the correct answer is AWS Lambda. So AWS Lambda, this is a serverless compute service that runs code in response to events without requiring you to provision or manage servers. EC2, this requires full server management. ECS and EKS, that require container orchestration setup. And Lambda, this is ideal for event-driven workloads. And our final question is, a company wants to ensure their web applications can handle sudden increases in traffic while maintaining availability. Which combination of AWS services best meets this requirement? Is it single EC2 instance only, auto scaling only, elastic load balancing only, or auto scaling with elastic load balancing? And of course, the answer is going to be auto scaling with elastic load balancing. So this combination provides both scalability and high availability. Auto scaling automatically adds or removes instances based on demand, and elastic load balancing, this distributes traffic evenly across those instances. And using both ensures no single server is overwhelmed, and the application can scale dynamically, and fault tolerance is improved. All right, so if you're preparing for the AWS exam, another important topic that you will encounter is AWS database services. And honestly, this isn't just exam knowledge. This is real world job ready knowledge, because every application that you interact with today, whether it's Netflix, Amazon, banking apps, or even your favorite game, they all rely heavily on databases behind the scenes. And as an IT professional, your ability to understand which databases to use, when to use it, and how to migrate data into the cloud is a huge differentiator. So with that being said, let's go. All right, so let's start with the foundation. When we talk about AWS database services, we're talking about a collection of fully managed and customizable database solutions offered by AWS. And these services allow organizations to store, manage, and retrieve data without worrying about the heavy lifting. We're talking about things like hardware patching, backup scaling, and high availability. Now, traditionally, companies had to build and maintain their own database servers in a data center, which meant buying expensive hardware, configuring RAID storage, installing database software, setting up replication, and constantly monitoring performance. Well, AWS flipped that entire model on its head. Now you can spin up a database in minutes, and not just any database, the right database for your particular job. And that's a key concept for this exam. Understand that AWS does not just give you one database solution. It gives you multiple, each designed for a specific use case. All right, so before we dive into specific services, you need to understand a core decision point. Meaning, should you run your database on an EC2 instance or use a managed AWS database service? So let me go ahead and break this down for you. So you got option one, which is your EC2 hosted database. And this means that you launch a virtual machine using Amazon EC2 and install your own database software like MySQL, PostgreSQL, or SQL Server. Now, if all of that sounds familiar to you, well, it's basically like running a traditional server, but in the cloud. And with this approach, you control everything. We're talking about the operating system configuration, the database installation, patching and updates, backup, security hardening, and scaling. And that level of control is great, but it also means more responsibility. And then you have option two, and this is AWS Managed Database Services. And this is where AWS shines. So instead of managing the database yourself, AWS handles the automatic backups, the software patching, high availability, failover, scaling, and monitoring. And you just basically focus on the application and not maintaining and setting up the infrastructure. So exactly which one of these should you choose? Well, here's the real world mindset and what AWS expects you to know for the exam. You would use EC2 hosted databases when you need full control over the operating system or database configuration, you're running legacy applications, or you have strict compliance requirements. You would use the managed services when you want to reduce operational overhead, you need scalability and reliability, and you want faster deployment. So for the exam, just remember this simple rule. If AWS can manage it for you, then that's usually the better choice. All right, so let's move on and talk about relational databases because this is the one that most people are familiar with. So relational databases, they store data in tables with rows and columns, and they use SQL or structured query language to query and manage data. And these are perfect for applications where relationships between data matters, like banking systems, HR systems, or e-commerce platforms. And within that, we have what is called Amazon RDS, or the Relational Database Service. And this is one of the most important services that you need to know. So think of Amazon RDS as a managed database platform that supports multiple database engines, including MySQL, PostgreSQL, Oracle, Microsoft SQL Server, and MariaDB. So instead of installing and managing the database yourself, RDS does it for you. And the key features are it offers automatic backups, it offers multi-availability zone deployments for high availability, it can read replicas for scaling, and it has automatic patching. Now, how does this apply in the real world? Well, just imagine you're building a web application that tracks customer orders. Well, if that's the case, you're going to need structured data, consistency, and relationships between tables. And guess what? RDS is a perfect fit. And then you have something called Amazon Aurora. And this is AWS's own relational database engine that is compatible with MySQL and PostgreSQL, but it is significantly faster and more scalable. And so Aurora was designed for high performance enterprise workloads and cloud native applications. Its benefits is up to 5 times faster than your standard MySQL. It automatically scales storage. It has built-in fault tolerance, and it can go serverless. So think of Aurora as RDS on steroids. So if you're asked on the exam which database is best for high performance relational workloads in AWS, then Aurora is often the answer. All right, so let's go ahead and switch gears real quick because not all data fits neatly into rows and columns, and that's where NoSQL databases come in. And NoSQL databases, they are designed for unstructured or semi-structured data. They are highly scalable and they offer low latency. And within that, we have what is called Amazon DynamoDB. And DynamoDB, this is a fully managed NoSQL database that uses a key value and document data model. And what makes this thing so powerful is it has single-digit millisecond latency. It offers massive scalability. You can go fully serverless, and there's no infrastructure management. So how does this relate to the real world? Or just think about a mobile application that needs to store user sessions or gaming leaderboards. Well, you don't need complex joins. You just need fast access to data, and that's DynamoDB all day. Now, for the exam, just remember this. If the question mentions high scalability, low latency, and flexible schema, then think about DynamoDB. All right, next let's talk about memory-based databases, because speed sometimes is everything, and this is where in-memory databases come into play. So instead of storing data on disk, these databases store data in RAM, making them incredibly fast. And the first one is called Amazon Elasticache, and this is AWS's managed in-memory database service. It supports Redis and Memcache, and you would use this for caching frequently accessed data, session storage, and real-time analytics. How this relates to the real world: let's say that your website gets millions of users. Instead of you querying your main database every time, you store frequently accessed data in Elasticache, and this reduces load and improves performance dramatically. Now, another service that you need to be aware of is Amazon MemoryDB for Redis. And unlike Elasticache, which is mainly for caching, MemoryDB is designed as a primary database with durability. And that means it has ultra-fast performance, data persistence, and high availability. And this is useful for applications that need both speed and reliability. All right, so let's talk about something that shows up in a lot of real world scenarios and on the exam, and that is database migration. Now, companies don't just start fresh in AWS. They often move existing databases from on-premises environments to the cloud, and AWS provides tools to make that process easier. And the first tool is the AWS Database Migration Service. And this basically helps you migrate databases with minimal downtime. So basically, you can migrate from on-premise to AWS, you can migrate between different database engines, and you can perform continuous data replication. How this relates to the real world is as follows. Just imagine that a company wants to move its Oracle database from a data center to AWS. Instead of shutting everything down, well, DMS will allow them to migrate the data while the system is still running, and that is a huge advantage. And then you have what is called AWS Schema Conversion Tool. And this is basically for if you are switching database types. So for example, you're going from Oracle to PostgreSQL or from SQL Server to MySQL. And that's where this tool comes in. So this tool can help convert database schemas. It can translate stored procedures, and it helps with compatibility. So think of it as a translator between database languages. All right, so at this point, you might be thinking, okay, that's a lot of services. And guess what? You're right. But here's the mindset AWS wants you to have. You need to choose the right database for the workload, because not every problem needs a relational database. Not every application needs DynamoDB, and not every system needs in-memory speed. So here's a simple mental framework that you can use, and hopefully it'll help you for the exam. If your data is structured and relational, you want to use RDS or Aurora. If your data is flexible and needs massive scale, you want to use DynamoDB. If you need ultra fast performance, you want to use Elasticache or MemoryDB. If you need to migrate your data, you want to use DMS or SCT. If you want full control, use ECT. And if you want simplicity, then use managed services. So with all that being said, here's the truth. Passing the AWS Cloud Practitioner exam, this isn't just about memorizing service names. It's about understanding why those services exist. So when you walk into an IT role, nobody's going to ask you, what is Amazon RDS? They're going to ask you, what database should we use for this application? And that's where this knowledge becomes powerful, because now you can think like this, meaning this application needs structured data. We're going to use RDS. This system needs to scale. We're rolling with DynamoDB. We need speed. We're rolling with Elasticache. We're migrating. We're going to use DMS plus SCT. And that's how you move from certification knowledge to real IT professional experience. And if you can explain these concepts in simple terms like you just learned here, then you are already ahead of a lot of people in the field. All right, so with that being said, let's do some check on learning. So our first question is, a company is building a web application that requires a structured database with relationships between tables such as customers, orders, and products. And they want AWS to handle backups, patching, and high availability. Which AWS service is the best fit? Is it Amazon DynamoDB, RDS, Elasticache, or EC2? And the answer is Amazon RDS. So this question clearly describes a relational database use case. We're talking about structured data with relationships. In Amazon RDS, this is a managed relational database service, meaning AWS handles backups, patching, and availability. Next question. A gaming company needs a database that can handle massive amounts of user data with extremely low latency and automatic scaling. The data does not require a fixed schema. Which AWS service should they use? Should they use Amazon Aurora, DynamoDB, MemoryDB for Redis, or RDS? And the correct answer is Amazon DynamoDB. So the keywords here are massive scale, low latency, and flexible schema. Amazon DynamoDB, this is designed for this type of workload. Aurora and RDS, these are relational databases, which are not ideal for flexible schemas at scale. And MemoryDB is fast, but is typically used for in-memory workloads, not large-scale primary NoSQL storage. And our final question is, a company wants to migrate to its on-premises Oracle database to AWS with minimal downtime. They also need to convert the database schema to be compatible with PostgreSQL. Which combination of AWS tools should they use? Should they use Amazon RDS and Amazon Elasticache? Should they use AWS Database Migration Service and AWS Schema Conversion Tool? Should it be Amazon EC2 and Amazon DynamoDB, or Amazon Aurora by itself? And the correct answer is they're going to use AWS Database Migration Service and AWS Schema Conversion Tool. So AWS Database Migration Service, this handles data migration with minimal downtime. And AWS Schema Conversion Tool, this handles schema and code conversion between database engines. Option A, this does not address migration. Option C, this is unrelated to migration tools. And option D is a database, not a migration solution. All right, so when you start diving into cloud computing, networking, this is one of those topics that can feel overwhelming or incredibly empowering, depending upon how it's explained. And if you're preparing for the AWS Cloud Practitioner exam, then understanding AWS networking services isn't just helpful, it is essential. And the good news is, you don't need to be a network engineer to get this. You just need to understand how AWS builds and secures networks in the cloud, and how all the pieces fit together. So think of AWS networking like building your own private internet inside the cloud. You're given full control over IP addressing, routing, security, and connectivity, but without having to physically plug in cables or configure hardware. Everything is virtual, scalable, and designed to work globally. So with that being said, let's go. All right, so at the center of AWS networking is the concept of a virtual private cloud, or Amazon VPC. And if you remember nothing else from this section, just remember this. A VPC, this is your private network in AWS. So imagine you're building a company office. You wouldn't just throw computers into an open field and hope for the best. You create rooms, define access points, control who can enter, and decide how everything connects. And that's exactly what a VPC does, but it does it in the cloud. So when you create a VPC, you define an IP address range using CIDR notation, and this determines how many resources you can have inside your network. And from there, you can carve up that network into smaller pieces called subnets. All right, so let's talk about subnets. Now, subnets, they are essentially smaller networks within your VPC, and they allow you to separate resources based on function, security level, or accessibility. There are two main types that you need to know. First is a public subnet, and these are resources that can access the internet. And then you have what is called a private subnet, and these are resources that are isolated from the internet. So for example, you might place a web server in a public subnet so users can access it, while your database sits in a private subnet for security. And this separation is huge in real-world environments because it reduces risk and follows the principle of least privilege, which is something AWS loves and exams test heavily on. Now let's talk about how your VPC communicates with the outside world. And the most important components here are the Internet Gateway and the NAT Gateway. So an Internet Gateway, this allows resources in a public subnet to communicate with the internet. And without it, your VPC is completely isolated. A NAT Gateway, or a Network Address Translation Gateway, on the other hand, this is used for private subnets, and it allows instances in private subnets to access the internet to where they can go search for updates and patches without being directly exposed to incoming traffic. So think of it like this. The internet gateway, this is equivalent to you opening the front door. The NAT gateway, this is equivalent to a one-way exit door. And this distinction is critical for both security and exam questions. All right, next let's talk about route tables. Now, every subnet in a VPC is associated with a route table, and this table determines where traffic goes. So for example, traffic to the internet, this goes to the internet gateway. Internal traffic, this stays within the VPC. So if you've ever configured a router before, well, this will feel familiar. If not, just think of route tables as the GPS system for your network. All right, next let's talk about security in a VPC. So security is where AWS networking really shines and where a lot of exam questions come from. There are two main layers of security inside of VPC. The first is called a security group. And a security group, this acts like a firewall at the instance level. So if you allow inbound traffic, then the response is automatically allowed back out. And that's what the word stateful means. An example of this would be you allowing HTTP or port 80 where users can access your web server. Then you have what is called a network ACL. And network ACLs are access control lists. They operate at the subnet level and they are stateless. And this means that you explicitly allow both inbound and outbound traffic. They provide an additional layer of control, and they are often used for broader rules. All right, so moving on, let's talk about DNS and traffic management. So when users type a domain name into their browser, something has to translate that into an IP address. And that's where Amazon Route 53 comes in. So Route 53, this is AWS's DNS or domain name system service, but it's not just a basic DNS. It's highly available, scalable, and packed with advanced routing features. So here's what you need to know. This thing can translate domain names into IP addresses. It routes users to the closest or healthiest endpoint, and it supports multiple routing policies. And examples of the routing policies include simple routing, weighted routing, latency-based routing, and failover routing. And in real-world scenarios, Route 53, this basically helps ensure that your application stays fast and available even during outages. All right, next, let's talk about edge services. So AWS doesn't just rely on centralized data centers. They use edge locations, which are small data centers spread across the globe to improve performance. And two key services here are as follows. The first is called Amazon CloudFront. So CloudFront, this is a content delivery network or a CDN where it caches content closer to users so websites can load faster. An example of this would be, let's say that you have a server that's in Virginia and you have a user that's in Japan. Well, when it comes to CloudFront services, they're going to get that content from a nearby edge location instead of making the request travel across the world. Then you have what is called AWS Global Accelerator, and this improves performance by routing traffic through AWS's global network infrastructure instead of the public internet. And this provides static IP addresses, faster failover, and improve latency. All right, next let's talk about connectivity options. So one of the most powerful aspects of AWS is the ability to connect your on-premises environment to the cloud. And there are two main options that you need to understand. The first is called AWS VPN, and this allows you to securely connect your local network to your VPC over the internet to where your traffic is encrypted, it's quick to set up, and it's cost effective. And this is perfect for smaller environments or temporary setups. And then you have what is called AWS Direct Connect, and this provides a dedicated physical connection between your data center and AWS to where it offers lower latency, more consistent performance, and higher bandwidth. And this is commonly used by large enterprises that need reliable, high-speed connections. All right, so at this point, you should start seeing how everything connects. A typical AWS network setup might look like this. You have a VPC that defines your network. You have subnets that organize your resources. You got gateways that connect you to the internet. You have route tables that control your traffic flow, security groups and network ACLs to protect your environment. You got Route 53, which handles your DNS and routing. You got CloudFront and Global Accelerator that improves your performance. And then you have a VPN or a direct connect that connects your on-premises network. And this isn't just a theory. This is exactly how real companies build cloud infrastructure. So why does any of this stuff matter? Well, if you're studying for the AWS Cloud Practitioner exam, then this section is less about memorizing commands and more about understanding concepts, because you're going to see questions like which service provides DNS, what's the difference between a security group and a network ACL, how do you connect your data center to AWS, and which service improves global content delivery. And if you understand the why behind the service, then those questions will be easy. But beyond the exam, this knowledge is what separates someone who knows AWS from someone who can actually design solutions. Because at the end of the day, every application, whether it's Netflix, Amazon, or a small business website, all of them rely on networking. And AWS gives you the tools to build that network faster, safer, and more efficiently than ever before. All right, so with all that being said, let's do some check on learning. So our first question is, which AWS service is primarily used to translate a domain like example.com into an IP address? Would this be Amazon CloudFront, AWS Direct Connect, a security group, or Amazon Route 53? And the correct answer is this will be Amazon Route 53. So Route 53 is AWS's DNS service, and its main purpose is to translate human readable domain names into IP addresses so users can reach websites and applications. CloudFront, this is used for content delivery. Direct Connect is for dedicated network connectivity, and security groups, they are used to control traffic to resources. Next question. What is the main difference between a security group and a network access control list and a VPC? Is it security groups are stateless while network ACLs are stateful? Is it security groups work at the subnet level while network ACLs work at the instance level? Is it security groups are stateful while network ACLs are stateless? Or is it security groups allow only outbound traffic while network ACLs only allow inbound traffic? And the correct answer is security groups are stateful while network ACLs are stateless. So security groups, they act like virtual firewalls for individual instances and are stateful, meaning return traffic is automatically allowed. Network ACLs, they operate at the subnet level and are stateless, meaning you must explicitly allow both inbound and outbound traffic. And this is a very common AWS exam topic. And our final question is, a company wants a dedicated private connection from its on-premises data center to AWS with more consistent performance than a VPN. Which service should they choose? Should they choose Amazon Route 53, AWS Direct Connect, Amazon CloudFront, or a NAT gateway? And the correct answer is AWS Direct Connect. So AWS Direct Connect, this provides a dedicated physical connection between an on-premises environment and AWS. It is designed for more consistent performance, lower latency, and higher bandwidth than a VPN, which uses the public internet. Route 53 is for DNS, CloudFront is for edge content delivery, and NAT Gateway, this is used to allow private subnet resources outbound internet access. All right, so storage in AWS isn't just where data sits. It's one of the most important design decisions you'll make in the cloud. It impacts performance, cost, scalability, security, and even compliance. So instead of memorizing a list of services, let's walk through it like you would in the field by making decisions based on real scenarios. With that being said, let's go. All right, so when you think about storage in the cloud, think about one simple question, and that is, what kind of data am I storing, and how do I need to access it? That one question will determine everything. In AWS, storage is broken down into a few major categories. We have object storage, block storage, file storage, and hybrid and cache storage. And each one solves a different problem. So if you mix them up, then your solutions either will not work well, or it's going to cost way more than it should. All right, so let's start with the most important one, and that is Amazon S3. So if AWS had a default storage service, then this would be it. So Amazon S3, which stands for Simple Storage Service. This is an object storage, which means that your data is stored as objects inside buckets, not as files on a disk like your laptop. And each object includes the data itself. It has the metadata, which is information about the data, and a unique identifier. So think of it like a massive, infinitely scalable Dropbox, but designed for applications, not just users. And when would you use S3? Well, you would use it when you need to store large amounts of data. You don't need to mount it like a traditional drive, and you want high durability. So think of the 11 nines, where basically you're never losing data. And a real world example of this would be somebody who's using website hosting to host static sites. You got backups and archives, you got media stores like videos and images, or think of data lakes that are used for analytics. All right, now here's where AWS gets interesting and where exam questions love to show up, because not all data is accessed the same way. And some data is used constantly while other data just sits there for years. And that's why S3 has different storage classes. So think of these like tiers. You got the S3 standard, and this is for frequently accessed data. It's fast, but it comes at a higher cost. You got what is called S3 intelligent tiering, and this automatically moves your data based upon your usage. You got S3 standard IA, or infrequent access. This is cheaper, but it offers a slightly slower access. You got S3 one zone IA. This is cheaper, but is stored in one availability zone. You got S3 Glacier Instant Retrieval, and it can archive with quick access. You got S3 Glacier Flexible Retrieval, and this takes minutes to hours for retrieval time. And then you got S3 Glacier Deep Archive, and this is the cheapest, but it takes hours to retrieve your data. Now, how does this work with the real world? So let's just say you're running a business and you don't want to pay premium storage for data that nobody touches. So you might store the active files in standard. You might move your older files to IA. You might archive your old backups into Glacier. And then that's where the lifecycle policies will kick in. And speaking of lifecycle policies, well, these are one of those features that separates beginners from professionals. So instead of manually moving data around, you tell AWS that after 30 days, move this to cheaper storage. After 1 year, archive it. And guess what? AWS will do it automatically. So let's say that you want to run a web application where your new logs, they can be stored in S3 standard. And after 30 days, they can be moved to S3 IA. After 90 days, you can move them to Glacier. Then after 1 year, they can be deleted. And all of this is going to save you money without you having to touch anything. And this is huge in real world environments where storage costs can quietly spiral out of control. All right, so let's go ahead and switch gears real quick. So when you're running a virtual machine in AWS, specifically in Amazon EC2 instance, you're going to need storage that behaves like a hard drive. And that's where block storage comes in. And the first one we have is called Amazon EBS, or Elastic Block Store. So EBS, this is persistent storage that you attach to EC2 instances. So think of it like your C drive on Windows or your root partition on Linux. And its key characteristics are: it is persistent, where the data stays even if the instance stops. It has high performance, and it is used for databases, operating system drives, and applications. And you would use this in the real world by hosting a MySQL database, running enterprise applications, or boot volumes for EC2. And then you have what is called the instant store, and this is the complete opposite. It is temporary storage. It is tied directly to the EC2 instance, and it is lost if the instance stops or terminates. Now, when would you use this? Well, you will use this when you need ultra-fast temporary storage, or you do not care about data persistence. And examples of this is caching and temporary processing of data, along with scratch space for computations. All right, so let's move on and talk about file storage. Now, imagine this scenario. You have multiple servers, and they all need access to the same files at the same time. That's where file storage comes in. And the first one we have is called Amazon EFS, or Elastic File System. And this is a scalable file system that multiple EC2 instances can access simultaneously. It uses standard file protocols like NFS, so it behaves like a shared network drive. And the use cases for this are web servers that share content management systems, and development and testing environments. You also have what is called Amazon FSx, and this provides fully managed file systems for specific use cases. And examples include Windows File Server, or SMB, and high-performance file systems like Lustre. And the real-world scenarios where you will find this is in enterprise Windows environments, high-performance computers, and media rendering workloads. All right, so let's move on and talk about hybrid and cache storage. So not every company is fully in the cloud, and many businesses are still running on-premises systems, and that's where AWS Storage Gateway comes in. And this thing acts as a bridge between your local environment and the AWS cloud. So what does it do? Well, it lets you cache frequently used data locally, and then you can store the rest in AWS. So an example would be a company might keep active files on site for speed and automatically back up everything to S3. And this is perfect for backup solutions, disaster recovery, and gradual cloud migration. And finally, let's talk about something people often overlook until it's too late, and that is backups. So AWS Backup, this is a centralized service that lets you manage backups across AWS resources. So instead of configuring backups individually for EBS, EFS, and RDS, you can just simply manage everything in one place. So why does this matter? Well, in real world environments, data loss can equal downtime, downtime can equal lost money, and lost money can equal angry stakeholders. In AWS backups, this basically helps enforce backup policies, retention rules, and compliance requirements. All right, so let's go ahead and simplify everything into a decision mindset. So when choosing AWS storage, ask yourself these questions. How is the data accessed? Is it over the internet? Then you're going to be dealing with S3. Is it mounted like a disk? You're going to be dealing with EBS. Is it shared across systems? Think EFS. Another question is, does it need to be persistent? If the answer is yes, you're dealing with EBS, S3, or EFS. If no, you're dealing with instant store. Another question is, how often is it used? If you're using the data frequently, then we're talking S3 standard. If you're using it rarely, then we're talking about Glacier. Another question is it hybrid? Meaning, is it on-prem plus the cloud? If yes, you're dealing with storage gateway. And then another question you need to ask is, do I need centralized backups? And if the answer is yes, then we're talking about AWS backup. Now, for the AWS exam, you're not expected to design massive architectures, but you are expected to recognize which storage service fits which use case, understand cost versus performance trade-offs, identify when to use object, block, or file storage, and know the basic services like S3, EBS, EFS, FSX, Storage Gateway, and AWS Backup. And if you could think like this, meaning you know what the right tool is for the right job, you're not only going to pass the exam, but you're actually going to understand AWS like a professional. So with that being said, let's do some check on learning. So our first question is, a company needs to store large amounts of data such as images and videos for a web application. The data must be highly durable, scalable, and accessible over the internet. Which AWS service is the best choice? Is it Amazon S3, Amazon EBS, Amazon EFS, or Instant Store? And the correct answer is going to be Amazon S3. So S3, this is designed for object storage, making it ideal for storing large amounts of unstructured data like images, videos, and backups. It also provides high durability, scalability, and web-based access, which makes it perfect for web applications. Next question. A solutions architect needs storage for an EC2 instance that behaves like a traditional hard drive and retains data even after the instance is stopped. Which option should they choose? Should they choose Amazon EBS, Instant Store, Amazon S3, or AWS Storage Gateway? And the correct answer is Amazon EBS. So Amazon EBS, this provides persistent block storage for EC2 instances. It behaves like a traditional hard drive and keeps data even when the instance is stopped. Instant Store, this is temporary, meaning the data is lost when the instance stops. And S3, this is object storage that is not used as a mounted drive and storage gateway. This is for hybrid environments. And our final question is, a company wants to reduce storage costs by automatically moving older, infrequently accessed data to cheaper storage tiers over time. Which AWS feature should they use? Should they use AWS Backup, Amazon FSX, Amazon S3 Lifecycle Policies, or Amazon EFS? And the correct answer is Amazon S3 Lifecycle Policies. So S3 Lifecycle Policies, they allow you to automatically transition data between storage classes like standard to IA to Glacier, or delete data after a certain period. AWS Backup, this manages backups. It is not a storage tier transition. And FSX and EFS are file storage services, and they do not handle lifecycle transitions. All right, so if you're preparing for the AWS Cloud Practitioner exam, then this is one of those subjects that can feel overwhelming at first. You start seeing a bunch of names like Amazon SageMaker, Amazon Lex, Amazon Athena, and it can feel like you're trying to memorize a phone book. But here's the reality. You don't need to memorize anything. You just need to understand what problem each service solves. That's it. And once you understand the purpose, then everything should hopefully click. So with that being said, let's get into it. All right, so before we jump into services, you need to understand the difference between two major categories. That is AI and machine learning. And these services, they can help you build intelligent applications, automate decision making, and recognize patterns, images, speech, or text. So basically, you need to be thinking about, can the system learn and make predictions or act intelligently? So when it comes to analytics services, these are the services that help you process large amounts of data, query, transform, or visualize data, or extract insights from raw information. So when it comes to that, you need to be thinking about, what is the data telling me? All right, so let's start with the AI machine learning side. And these services are all about making your application smarter without you needing to be a data scientist. All right, so the first one we have is called Amazon SageMaker. So if AWS AI ML services were a gym, then SageMaker would be the full training facility. And this is where you go to when you want to build machine learning models, train them on data, and deploy them into production. So think of it like this. You're creating a system that predicts whether a customer will cancel their subscription. Well, SageMaker will let you build that predictive model from scratch or use pre-built tools. And what makes SageMaker powerful is that it handles the entire machine learning lifecycle, from data preparation, model training, model tuning, and deployment. So for the exam, just remember this: SageMaker. This means you are building, training, and deploying machine learning models. And then we have what is called Amazon Lex. So if you ever interacted with a chatbot or a voice assistant, then Lex is the kind of service behind it. It uses automatic speech recognition and natural language understanding. So basically, just imagine that you create a chatbot for a bank that can answer questions like, what's my balance, or transfer my money. Well, Lex, it integrates with other AWS services to actually do things and not just talk. So for the exam, just understand that Lex, this is basically chatbots and conversational interfaces. And then we have this thing called Amazon Kendra. And Kendra, this is like a supercharged search engine for your organization. So instead of keyword-based search, it understands context. So an example would be, an employee types, how do I request PTO? Well, Kendra doesn't just search for keywords, it finds the actual answers from documents. So for the exam, just understand that Kendra, this is basically intelligent enterprise search. Then we have other AI machine learning services that you should recognize. So AWS has a bunch of pre-built AI services that solve very specific problems, and you don't need deep knowledge on this. You just need to know what they do. So here are some of the key ones. You got what is called Amazon Recognition. This is for image and facial recognition. So think of identifying objects or people in photos. You got what is called Amazon Poly. This converts text into lifelike speech. You got Amazon Transcribe. This converts audio into text. You got Amazon Comprehend. This analyzes text for sentiment, entities, and meaning. You have what is called Amazon Textract, and this extracts text and data from documents like invoices. So here's how to think about all of these. These are plug and play AI services. You're not building models, you're just using them. All right, so let's go ahead and shift gears to analytics. So this is where AWS shines when it comes to handling massive amounts of data. First thing we're going to talk about is called Amazon Athena. And basically, Athena lets you run SQL queries directly on data stored in Amazon S3, where you don't need any server or any infrastructure to interact with this thing. So an example would be, you have logs stored in S3 and want to analyze them. Instead of loading them into a database, you just query them directly using SQL. So for the exam, just understand that Athena, this equals serverless SQL queries on S3 data. You also have what's called Amazon Kinesis. And basically, this is for real-time data processing. So think of streaming logs, IoT data, and live analytics dashboards. So an example of how you would use this, just think of a ride-sharing app that tracks driver locations in real time. Well, Kinesis will help ingest and process that data as it happens. So for the exam, just understand that Kinesis equals real-time streaming data. And then there's a product called AWS Glue. And Glue is used for ETL, which stands for extract, transform, and load. And this basically helps you clean data, move data between systems, and prepare data for analytics. So just imagine that you take raw data from multiple sources, you clean it, and then you load it into a data warehouse. So when it comes to the exam, just understand that AWS Glue, this equals ETL and data preparation. And then finally, we have what is called Amazon QuickSight. And this is AWS's business intelligence tool where it helps you create dashboards, visualize data, and share insights. An example could be a company that tracks sales performance with interactive charts and graphs. So for the exam, just understand that QuickSight, this is all about dashboards and data visualization. All right, so exactly how do all of these services work together? Well, here's a real world pipeline. So just think about data that's generated. We're talking about website clicks and application usage. You got Amazon Kinesis that'll stream the data in real time. You got AWS Glue that will clean and prepare the data. Then the data is going to be stored in S3. Amazon Athena is going to query that data. The Amazon QuickSight is going to visualize it. And then Amazon SageMaker may use that data to build predictive models. That is the ecosystem. And honestly, that's exactly what AWS wants you to understand for this exam. So let me go ahead and wrap all this stuff up. So here's what you need to understand. You don't need to memorize the features. You just need to understand their use cases. So if you see a question like, which service would you use to build a machine learning model? You should automatically be thinking about SageMaker. If you see a question that says something like query data stored in S3 using SQL, the answer is going to be Athena. If it says something like create dashboards, we're talking about QuickSight. If it says something like process streaming data in real time, we're talking about Kinesis. If it says something like clean and transform your data, we're talking about Glue. And if it says something about building a chatbot, then we're talking about Lex. That's how you make sense of all this craziness. Now, let me go ahead and bring this back to the real world because this is where things get exciting. As an entry-level IT professional, you may not be building machine learning models on day one, but you will work with data. You will support applications that use AI, and you will help organizations make data-driven decisions. Now, understanding these services is going to give you a huge advantage. Why? Because companies today are moving to cloud-native analytics. They're using AI to automate processes, and they're relying on data for everything. And AWS is at the center of all of that stuff. So if there's one thing that I want you to walk away with, it is this. AWS AI and machine learning services, they make applications smarter. The AWS analytics services, they help you understand the data. That's it. You don't need to be a data scientist and you don't need to memorize every single feature. You just need to understand what problem each service solves and when to use it. And once you do that, then this objective becomes one of the easiest points on the exam. So with all that being said, let's do some check on learning. Our first question is, a company wants to build a machine learning model that predicts customer churn and deploy it into production. Which AWS service should they use? Would it be Amazon QuickSight, Amazon Athena, AWS Glue, or Amazon SageMaker? And the correct answer is going to be Amazon SageMaker. So SageMaker, this is specifically designed to build, train, and deploy machine learning models. And this makes it the best choice for predictive analytics like customer churn. Next question. A data analyst needs to run SQL queries directly on data stored in Amazon S3 without managing any servers. Which AWS service should they use? Would this be Amazon Kinesis, Amazon Athena, Amazon Lex, or Amazon Kendra? And the correct answer is going to be Amazon Athena. So Athena, this allows you to run SQL queries directly on data stored in S3 without provisioning infrastructure. And our final question is, a company wants to create real-time dashboards based on streaming data from IoT devices. Which combination of AWS services best fits this requirement? Would this be Amazon Kinesis and Amazon QuickSight, Amazon Lex and Amazon Recognition, AWS Glue and Amazon Poly, or Amazon SageMaker and Amazon Kendra? And the correct answer is going to be Amazon Kinesis and Amazon QuickSight. So Kinesis, this handles real-time data ingestion and streaming. And QuickSight, this provides dashboards and visualizations. Together, they allow you to process live data and display it in real time. All right, so if you're studying for the AWS Cloud Practitioner exam, then one thing you'll quickly realize is that AWS isn't about spinning up virtual machines or storing files in the cloud. AWS is an entire ecosystem that's massive, layered, and packed with services designed to solve very specific business and technical problems. And this objective is where AWS really starts testing whether you understand how all of these services fit together across different categories. This is where beginners often get overwhelmed, but also where things start to click. So with that being said, let's go. All right, so let's start with one of the most important categories, and that is application integration. So, in the real world, systems do not operate in isolation. You've got apps that talk to databases, services triggering other services, and events happening constantly. AWS gives you tools to glue everything together. And the three core services that you need to know about are Amazon Event Bridge, Amazon Simple Notification Service, and Amazon Simple Queue Service. So, think of these as different ways to handle communication between systems. When it comes to Amazon Event Bridge, this is all about event-driven architecture. So imagine your application generates events like a user signing up, a file being uploaded, or a payment being processed. Event Bridge listens for those events and routes them to the right destination. It's like an intelligent dispatcher that says, hey, something just happened. Who needs to know about it? And then you have what is called Amazon SNS, and this is all about broadcasting messages. It's a publish subscribe system. So when something happens, SNS can send notifications to multiple subscribers at once, like email, SMS messages, Lambda functions, or even HTTP endpoints. So picture it like sending out a mass alert. And then you have what is called Amazon SQS, which works differently. So SQS, this is a message queue, meaning it stores messages temporarily so they can be processed later. And this is critical for decoupling systems. So instead of one service waiting on another, messages are placed in a queue and processed asynchronously. And this improves reliability and scalability. Now, for an exam perspective, here's how you need to think about this. If you need real-time notifications, then we're talking about SNS. If you need reliable messaging processing, we're talking about SQS. And if you need event-based automation, then we're talking about Event Bridge. And in the real world, companies, they often use all three of these together. All right, so let's go ahead and shift into services that directly support business operations. And the two big players here are Amazon Connect and Amazon Simple Email Service. So Amazon Connect, this is AWS's cloud-based contact center solution. So think call centers, customer support lines, and help desks, all running within the cloud. So instead of building expensive infrastructure, businesses, they can quickly set up a contact center with voice, chat, and integration into other AWS services. And then we have Amazon SES, and this is all about sending emails at scale. So whether it's transactional emails like password resets or marketing campaigns, SES, this allows businesses to send large volumes of email reliably and cost effectively. Now, from an exam standpoint, if the question mentions customer support, then once again, we're talking about Amazon Connect. If it talks about sending emails, then we're talking about Amazon SES. Now, in real world terms, these services, they help companies stay connected with their customers efficiently. All right, now let's talk about something that often gets overlooked, and that is AWS support and engagement services. And these include AWS Activate for startups, AWS IQ, AWS Managed Services, and AWS Support. Now, these aren't just technical services in the traditional sense. They're about helping customers succeed on AWS. So AWS Activate, this is designed for startups. It provides credits, training, and resources to help new businesses get up and running in the cloud. You have what is called AWS IQ. This connects customers with AWS certified experts who can help with projects. So think of it as hiring a freelancer who specializes in AWS. Then you have what is called AWS Managed Services, and this takes operational responsibility off of your plate. And AWS helps manage your infrastructure so your team can focus on business goals instead of day-to-day maintenance. And then you have AWS Support, and this is exactly what it sounds like. This is technical support plans ranging from basic to enterprise level. So for the exam, this category is just about understanding when the company needs help. So if you're a startup that's trying to grow, then you're going to roll with AWS Activate. If you need expert help, you're going to deal with AWS IQ. If you want AWS to manage your operations, then we're dealing with AMS. And if you need technical support, then we're dealing with AWS Support. All right, so here's where things get exciting, especially if you're into DevOps or software development. So AWS, it provides a full suite of developer tools, including AWS Cloud9, Cloud Shell, Code Commit, Code Build, Code Deploy, Code Pipeline, Code Architect, Code Star, App Config, and X-Ray. So let me go ahead and break this down into a real world scenario. Imagine that you're building an application. You need to write code, store it, build it, test it, deploy, and monitor it. Well, Cloud9, this is going to give you a cloud-based IDE, so there's going to be no need to install anything locally. Cloud Shell, this is going to let you run commands directly in the browser. Code Commit, this is your version control system like GitHub. Code Build, this helps you compile and build your code. Code Deploy, this is going to push your application to the servers. Code Pipeline, this is going to automate the entire CI/CD process. Code Artifact, this is going to store dependencies like libraries and packages. Code Star, this is going to help manage development projects. App Config, this is going to allow dynamic configuration changes without redeploying the code. And X-Ray, this is going to help you trace and debug your applications. Now, for the exam, the key skill is recognizing the life cycle. So when it comes to writing, once again, we're talking about Cloud9. When it comes to storing, we're talking about code commit. When we're talking about building, we're talking about code build. Deploy, code deploy. Automate, code pipeline, and monitoring, X-Ray. That is the entire DevOps process in action. All right, so now let's talk about delivering computing environments to users. And the key services are Amazon AppStream 2.0, Amazon Workspaces, and Amazon Workspaces Web. So Amazon Workspaces, this provides full virtual desktops in the cloud, so users can log in from anywhere and access a complete desktop environment. Then there's Amazon AppStream 2.0, which is more focused because it streams individual applications instead of full desktops. And you have Amazon Workspaces Web. This allows secure browser-based access to internal websites and SaaS applications. So for the exam, just understand that full desktops, we're talking about workspaces, streaming applications, we're talking about AppStream 2.0, and browser-based access, we're talking about Workspaces Web. And these services are especially useful for remote work and secure environments. All right, so now it's time to move into front-end development. And the two main services are AWS Amplify and AWS App Sync. So AWS Amplify, this is designed to help developers build and deploy full stack web and mobile applications quickly to where it can handle hosting, authentication, APIs, and a whole bunch of other stuff. You have AWS App Sync, and this is focused on APIs, specifically GraphQL APIs, and this allows applications to efficiently retrieve and update data in real time. So in simple terms, Amplify, this is about building and deploying applications. App Sync, this is about managing data and APIs. So if the exam question mentions mobile apps or front-end hosting, then Amplify is usually the answer. And finally, let's talk about IoT, or the Internet of Things. And the key services are AWS IoT Core and AWS IoT Greengrass. So IoT Core, this allows devices to connect to the cloud securely. So think about smart thermostats, sensors, or industrial machines sending data to AWS. And then IoT Greengrass, this extends AWS capabilities to local devices to where it allows devices to process data locally, even when offline. Now for the exam, just understand that when you're talking about connecting devices to the cloud, we're talking about IoT Core. And if we're talking about local processing on devices, then we're talking about Greengrass. All right, so now that you've seen all of these services, here's the real skill AWS is testing, and that is decision making. The exam isn't asking you, what does SNS do? It's asking you, given a scenario, which service would you choose? That's a big difference. You need to think about it like this. So if a company needs alerts, we're talking about SNS. If they need message buffering, we're talking about SQS. If they need event routing, we're talking about Event Bridge. If they need email, we're talking about SES. If they need a call center, we're talking about Connect. They need CI/CD, we're talking about Code Pipeline. Debugging, we're talking about X-Ray. You need some virtual desktops, we're talking about Workspaces. You need some streaming applications, we're talking about AppStream. You need some mobile applications, we're talking about Amplify. You need some APIs, we're talking about App Sync. And if you need IoT connectivity, we're talking about IoT Core. This is the mindset that separates memorization from understanding. But here's the truth. AWS is not about knowing everything. It's about knowing where things fit. This objective is testing whether you understand the ecosystem. Can you connect the dots between services, and can you choose the right tool for the job? Because in the real world, that's exactly what cloud professionals do every day. They don't memorize, they analyze. They look at a problem, they break it down, and they say, what's the most efficient, scalable, and cost-effective AWS service for this? And that's exactly what you're learning to do here. So as you study, don't just memorize the service names, visualize scenarios, think about real businesses, and imagine yourself in that role. Because once you start thinking like that, not only will you pass the exam, but you will be ready for the real world. So with all that being said, let's do some check on learning. So our first question is, a company wants to send real-time alerts to multiple subscribers via email, SMS, and Lambda functions. Whenever a critical system event occurs, which AWS service should they use? Would it be Amazon SQS, Amazon SNS, Amazon Event Bridge, or AWS Code Pipeline? And the correct answer is Amazon SNS, which stands for Simple Notification Service. And this is designed for publishing and subscribing messages, meaning it can broadcast messages to multiple subscribers simultaneously. Next question. A development team wants to automate the process of building, testing, and deploying code whenever changes are pushed to a repository. Which AWS service best fits this requirement? Is it AWS Code Commit? Is it Code Build, Code Pipeline, or Code Deploy? And the correct answer is AWS Code Pipeline. So Code Pipeline, this is used to automate the entire CI/CD workflow, including pulling the code from a repository, building and testing it, and deploying it automatically. And our final question is, a company needs to provide employees with secure cloud-based desktops that they can access from anywhere. Which AWS service should they choose? Should they choose Amazon AppStream 2.0, Amazon Workspaces, AWS Amplify, or AWS IoT Core? And the correct answer is Amazon Workspaces. So Workspaces, this provides full virtual desktops in the cloud. AppStream 2.0, this streams individual applications, not full desktops. Amplify does front-end web and mobile development. And IoT Core, this connects IoT devices. All right, so when you first step into the world of cloud computing, pricing can feel like one of the most confusing parts of the journey. And honestly, that's a fair assessment because unlike traditional IT, where you buy hardware up front and call it a day, AWS flips the script entirely. You're paying for what you use, when you use it, and sometimes even how you use it. And that flexibility is power, but only if you truly understand it. So with that being said, let's get into this lesson. All right, so let's start with the foundation. AWS, it operates on a pay-as-you-go pricing model, meaning you're billed based on actual consumption. No long-term commitments are required unless you choose them. There are no upfront infrastructure costs and no guessing how much hardware you're going to need. But here's where things get interesting. AWS gives you multiple ways to pay for the same compute resources, and each option is designed for a specific use case. And that's where your decision-making skills come into play, because choosing the wrong pricing model can cost your organization serious money. So think of AWS pricing like choosing between paying full price whenever you want, that's flexibility, or signing a contract for cheaper rates, that shows commitment, or bidding on unused inventory. And now we're talking risk versus reward. So let me go ahead and break all this stuff down for you. All right, so let's talk about on-demand instances, and this offers maximum flexibility. Now, this is the easiest one to understand. With on-demand instances, you pay for compute capacity by the second or hour, depending upon the service, with no long-term commitment. So if you spin up an EC2 instance and run it for 10 minutes, then you only pay for 10 minutes. That's how simple this is. So this is perfect for short-term workloads, testing and development, and applications with unpredictable traffic. But here's a catch. This is also the most expensive option in the long run. So think of it like using Uber every single day instead of owning a car. Is it convenient? Absolutely. Is it cost-effective long-term? Not really. And then we have what are called reserve instances, and these are predictable and they offer savings. So now we're talking about getting into optimization. So reserve instances, they allow you to commit to using a specific instance type for 1 or 3 years in exchange for significant discounts, sometimes up to 72% compared to on demand. And here's what makes RIs important for the exam in real life. You're basically locking in a capacity reservation and pricing discount, and this is best for steady state workloads like databases or always on applications. But let's talk about flexibility, because this is where many people get confused. So we have what is called reserve instance flexibility. There are 2 main types. First one is called a standard RI, and this has the highest discount but is less flexible. You have what is called a convertible RI. This has a lower discount, but you can change instant types. So for example, if your company originally needed a T3 medium, but later needs a T3 large, then convertible RIs, they will allow you to adjust without losing your investment. And this is huge in real world environments where requirements change constantly. Now let's talk about reserve instances in AWS organizations. And this is where we level up. So if you're working in an environment using AWS organizations, the reserve instances don't just apply to one account. They can be shared across multiple accounts under the same organization. So what does that mean? Well, if one team isn't fully using their reserve capacity, then another team can automatically consume it. And this leads to better cost efficiency across the company, not just one department. And in real enterprise environments, this is a game changer. Now let's talk about one of the most interesting options, and that is spot instances. So AWS sells unused compute capacity at huge discounts of up to 90%. Now that sounds amazing, right? But here's the catch. AWS can terminate your instance at any time if that capacity is needed elsewhere. So when would you use a spot instance? Well, you would use it if you're doing batch processing, data analysis, fault tolerance workloads, or background jobs. This is not ideal for critical applications, databases, or anything requiring consistent uptime. So think of spot instances like airline standby tickets. They are cheap, but they are not guaranteed. Then we have what are called savings plans. And savings plans, these are AWS's more modern approach to reserve instances. So instead of committing to a specific instance type, you commit to a certain amount of usage, like $10 an hour. In return, you get discounted rates. And there are two main types. The first is called the compute savings plan, and this is the most flexible, and this applies across EC2, Lambda, and Fargate. Then you have EC2 instance savings plans, and these are slightly less flexible, but they offer higher savings. And this is ideal for organizations that want predictable billing and flexibility across services. So in real world terms, this is like saying, I promise to spend this much money with AWS, just give me a discount. And now we're going to move into specialized pricing, because some organizations, especially those dealing with compliance or licensing, they need physical isolation. And that's where these come in. So we have what is called a dedicated instance, and this runs on hardware that is dedicated to a single computer. Then we have what's called a dedicated host, and this gives full control over the physical server. So why would you need this? Well, you would need this because you're dealing with regulatory compliance, software licensing requirements, or you have some security concerns. And these options are more expensive, but they are necessary in certain industries like healthcare or finance. And then we have what is called a capacity reservation. So imagine launching a critical application and finding out there's no available capacity. That's where capacity reservations come in, because they allow you to reserve compute capacity in a specific availability zone, ensuring your instance can launch when needed. Now, the important distinction here that you need to understand is that you pay for the reserve capacity whether you use it or not. And this is about availability, not discounts. And this is commonly used for disaster recovery or high priority workloads. All right, so let's go ahead and talk about something that catches a lot of beginners off guard, and that is data transfer pricing. So here's the key concept that you need to remember for both the exam and real life. Inbound data is usually free, and outbound data usually costs money. So incoming data, this is also known as ingress. This is data coming into AWS, and this is generally free. So for example, we're talking about uploading files to S3 or sending data to an EC2 instance. All of that comes at no charge. Then we have what is called outgoing data. This is also known as egress, and this is where costs start adding up, because you were charged for data that leaves AWS to go to the internet. They're also charged for data transferred between regions, and sometimes even between availability zones. So let me go ahead and break this down. Within the same availability zone, it is usually free. Between availability zones in the same region, you're going to pay a small cost. Between regions, you're going to pay a higher cost. And between AWS and the internet, you're going to pay the highest cost. And this is why architecture design matters, because a poorly designed system that moves data across regions unnecessarily, they can rack up some huge bills. All right, so next let's talk about storage pricing. So storage in AWS is another area where pricing varies based on usage patterns. So let's focus on Amazon S3 since it's the most commonly tested service. So when it comes to storage tiers in S3, AWS offers multiple storage classes designed for different access patterns. The first is called S3 Standard, and this is frequently accessed and it comes at a higher cost. You have what's called S3 Intelligent Tiering, and this automatically moves data to cheaper tiers. You got S3 Standard IA, or infrequent access, and this comes at a lower cost and the retrieval is free. You got S3 One Zone IA. This is cheaper, but has less redundancy. You got S3 Glacier. This is an archival storage at a very low cost. And then you got S3 Glacier Deep Archive, and this is the cheapest, but it also has the slowest retrieval. Now, here's the real world takeaway. If you access data frequently, then you're going to pay more money and get faster access. If you rarely access data, you're going to pay less, but you're going to wait longer to retrieve it. So this is all about aligning costs with usage patterns. Now let's talk about storage pricing factors. So when pricing storage, AWS considers the amount of data that's going to be stored, meaning how many gigabytes per month, the number of requests, your data retrieval costs, and your data transfer costs. So even storage isn't just pay for space, it is usage based. All right, so let's bring all of this together in a practical way. So if you're an entry-level IT professional or you're studying for this exam, the biggest skill you need is knowing when to use each pricing option. So here's how to think about it. If you need flexibility, you're going to use on demand. If you have predictable workloads, you're going to use reserve instances or savings plans. If you want maximum savings and you can tolerate interruptions, you're going to use spot instances. If you need compliance or isolation, you're going to use dedicated hosts or instances. And if you need guaranteed capacity, you're going to use capacity reservations. And in real life, most organizations, they use a combination of these. All right, so let's put all of this together. So let's say your company is running a web application where they're getting steady traffic and they have a data analytics pipeline that they're using for batch processing, and they have a disaster recovery system. So here's how you might optimize your costs. When it comes to web applications, you're going to use reserve instances or savings plans. When it comes to analytics jobs, you're going to use spot instances. When it comes to disaster recovery, you're going to use capacity reservations. Because if you do all of that, you're going to be balancing cost savings, performance, and reliability. And that's exactly what AWS expects you to understand for the exam. So at the end of the day, AWS pricing isn't just about memorizing terms for an exam. It's about thinking like a cloud professional, because every decision that you make comes down to trade-offs. We're talking about cost versus flexibility, savings versus commitment, performance versus price. Now, if you could look at a workload and say, what's the cheapest way to run this without breaking it, you're already ahead of most beginners. And that's really what this exam objective is testing, not just what these pricing models are, whether you understand why and when to use them. All right, so with all that being said, let's do some check on learning. So our first question is, a company runs a web application that has consistent, predictable usage 24/7. They want to reduce costs while maintaining reliability. Which AWS pricing option is most appropriate? Would it be on-demand instances, spot instances, reserve instances, or dedicated hosts? And the correct answer is reserve instances. So reserve instances, they are ideal for steady state predictable workloads like a web application running continuously. By committing to a 1 or 3 year term, the company can significantly reduce costs compared to on-demand pricing. Next question. Which statement best describes AWS data transfer pricing? Is it both incoming and outgoing data transfers are always free? Is it incoming data transfer is typically free, but outgoing data transfer is charged? Is it ongoing data transfer is free within all AWS regions? Or is it data transfer costs only applied to storage services? And the correct answer is incoming data transfer is typically free, but outgoing data transfer is charged. So AWS generally allows free inbound data transfer, also known as ingress, but charges for outbound data transfer, also known as egress, especially when sending data to the internet and transferring data between regions. And understanding this is critical because poor architecture decisions, this can lead to unexpected costs. And our final question is, a company runs batch processing jobs that can tolerate interruptions and wants to minimize compute costs. Which AWS pricing model should they choose? Should they roll with spot instances, on-demand instances, reserve instances, or capacity reservations? And the correct answer is spot instances. So spot instances, they provide deep discounts of up to 90%, but can be terminated at any time by AWS. This makes them perfect for batch jobs, data processing, and fault tolerance workloads. However, they are not suitable for applications that require high availability or uninterrupted execution. All right, so when you first step into the world of AWS, everything feels exciting. We're talking about on-demand servers, scalable storage, global infrastructure at your fingertips. But here's the reality that every cloud practitioner quickly learns. If you don't understand billing and cost management, that excitement can turn into a surprise bill real fast. And that's exactly why the AWS Cloud Practitioner exam puts heavy emphasis on understanding billing, budgeting, and cost control tools. So with that being said, let's go. All right, so in traditional IT environments, you bought hardware up front. You knew the costs, you paid once or you financed it, and that was it. With AWS, you're operating in a pay-as-you-go model, which means you pay for what you use, you stop paying when you stop using it, and your cost, they can scale up or out of control very quickly. And this flexibility is powerful because it also introduces responsibility. Now, as an IT professional, you're expected to understand not just how to deploy resources, but how much those resources cost and how to control those costs. So think about it like this. Spinning up a virtual machine in AWS can take seconds. Forgetting to turn it off could cost you money for days, weeks, or even months. All right, so let's talk about AWS billing support and information. So the first place you'll interact with AWS cost management is the billing dashboard. And this is your central hub for everything related to costs. Inside the AWS billing dashboard, you can view current changes, track month-to-date spending, access past invoices, break down costs by the services that you use, and monitor usage trends. Also, AWS provides detailed billing reports, which means you can see exactly where your money is going. And this level of transparency is one of AWS's biggest strengths. Now, AWS also provides different levels of billing support depending upon your support plan. You have the basic support plan, which is free. You got your developer support, business support, and enterprise support. And the higher tier plans, they can give you access to faster response times and more in-depth billing assistance, which is especially useful for organizations running large-scale cloud environments. Now, in the real world, this matters because finance teams, IT teams, and management, all of them rely on this data to make decisions. So if you're working in IT or cloud operations, you'll often be asked questions like, why did our bill increase this month? Which service is costing us the most? And can we reduce our spending? And that's where your knowledge becomes valuable. All right, so let's talk about AWS pricing models because AWS doesn't just have one pricing model, it has several. Understanding this is critical. So the first is on-demand pricing. And this is the default model. So basically you pay for compute, storage, or services by the second or hour, depending upon the service. There's no upfront costs, no long-term commitment, and it is the most flexible, but also it is the most expensive per unit. We have what are called reserve instances. And basically you commit to using a resource for 1 or 3 years, and in return, you get a discount. And this presents significant cost savings. It's less flexible, but it is best for predictable workloads. And then you have savings plans. And this is a newer, more flexible version of reserve instances. And basically you commit to a certain amount of usage, like $10 an hour. And this automatically applies discounts across your services. And then you have what are called spot instances, where you bid on unused AWS capacity, where this can be up to 90% cheaper. However, it can be interrupted at any time. But this is perfect for batch jobs, testing, or non-critical workloads. Now, before you deploy anything, AWS gives you a powerful tool, and that is called the AWS Pricing Calculator. And this tool allows you to estimate costs before launching resources, compare different configurations, and build cost projections for projects. So for example, let's say you're planning a web application. Well, you can estimate the EC2 instance costs, your storage costs, your data transfer costs, and your database costs. And this is huge in real world environments because businesses don't just deploy resources blindly, they budget first. And as a cloud practitioner, you'll often be asked to provide cost estimates before a project even starts. Now let's talk about control. So AWS budgets, this is one of the most important tools for preventing overspending. With AWS budgets, you can set a monthly cost limit like $500 a month. You can track usage across that limit, and you can receive alerts when thresholds are exceeded. So for example, you can get an alert at 50% usage, 80%, or even 100% usage. And you can even trigger automated actions like stopping resources. And this is incredibly useful in training labs, development environments, and startups trying to control costs. So in real life, budgets, they are essentially your safety net. And then we have what is called the AWS Cost Explorer. So if AWS budgets is about control, then the Cost Explorer is about analysis. And Cost Explorer, this allows you to visualize spending over time, identify trends, break down costs by service, region, or tag, and forecast future costs. So imagine you notice your AWS bill increased this month. Well, Cost Explorer will help you answer, was it EC2? Was it storage, or did a new service get deployed? And you can also even drill down into specific time ranges and usage types. And this tool is heavily used in real world environments by people like cloud engineers, the finance team, and DevOps teams. And then you have what is called the AWS Billing Conductor. So now we're stepping into the enterprise territory, and AWS Billing Conductor, this is designed for organizations that need custom billing views. And this allows you to create custom pricing models, allocate costs across departments, and simulate internal chargeback systems. So for example, a company might want to charge the marketing team differently than the engineering team. They might want to apply internal pricing rules, or they might want to show costs in a simplified format. And this is especially useful for large organizations with multiple teams or business units. And now let's talk about AWS organizations and consolidated billing. So let's say your company has multiple AWS accounts, maybe one for development, one for production, and one for testing. Well, managing billing separately, this could be a nightmare. And that's where AWS organizations come in. And with AWS organizations, you can group multiple AWS accounts, apply policies across accounts, and enable consolidated billing. Now, exactly what is consolidated billing? Well, instead of each account getting its own bill, all the costs are combined into one bill. You get discounts like on reserved instances, which can be shared, and you get a unified view of spending. And this is huge for enterprises because it simplifies billing and maximizes savings. And now here's where things get really interesting and really important. So we're talking about cost allocation tags, and these things allow you to assign metadata to AWS resources. So for example, if you have a project, you can assign a tag like website redesign. Another tag for department could be marketing. Another tag for environment could be production. And basically these tags help you track costs more effectively. And there are two main types. The first is your AWS generated tags. And these are automatically created by AWS. And then you have your user-defined tags, and these are created by you for tracking purposes. And once enabled, these tags appear in billing reports and tools like Cost Explorer. Now, if you want the most detailed billing data possible, then AWS provides what is called the Cost and Usage Report. And this report includes hourly usage data, detailed cost breakdowns, and resource level information. And it's typically stored in Amazon S3 and can be analyzed using tools like Excel, BI tools, and data analytics platforms. In enterprise environments, this is often used for financial reporting, auditing, and cost optimization strategies. All right, so here's the things that you need to understand for the exam. AWS gives you visibility. We're talking about billing dashboards and Cost Explorer. AWS also gives you control. We're talking about budgets and billing conductor. AWS gives you planning tools like the pricing calculator. And AWS gives you organization like organizations and tags. And your job is to understand when and why to use each one. Because at the end of the day, cloud isn't just about spinning up servers. It's about managing resources responsibly. So if you can estimate cost before deployment, monitor usage in real time, analyze trends and anomalies, control spending with budgets, and organize costs across teams, then you're not just passing the AWS Cloud Practitioner exam, you're thinking like a real cloud professional. And that's what separates someone who knows AWS from someone who can actually work in AWS. So with all that being said, let's do some check on learning. So our first question is, a company wants to receive alerts when their AWS costs exceed a predefined monthly limit and potentially take action to prevent overspending. Which AWS service should they use? Should they use AWS Cost Explorer, Budgets, Pricing Calculator, or Billing Conductor? And the correct answer is going to be AWS Budgets. So budgets, this is specifically designed to set spending thresholds and trigger alerts when those thresholds are exceeded. It can even automate actions like stopping resources. Next question. An organization wants to analyze trends in their AWS spending over time and identify which services are contributing the most to their bill. Which tool should they use? Should they use AWS Cost Explorer, Budgets, Organizations, or the Pricing Calculator? And the correct answer is they're going to use the AWS Cost Explorer. So Cost Explorer, this is used to visualize and analyze AWS spending over time. It allows you to break down costs by service, regions, or tags. You can identify usage trends, and it can help you forecast future spending. And our final question is, a company uses multiple AWS accounts for different departments and wants a single bill with shared discounts across all accounts. Which AWS feature should they use? Should they use AWS cost allocation tags, the pricing calculator, budgets, or organizations with consolidated billing? And the answer is AWS organizations with consolidated billings. So AWS organizations enable centralized account management and consolidated billing. And this allows one combined bill across all accounts, sharing of discounts like reserved instances or savings plans, and it makes for easier cost tracking and governance. All right, so when you're getting into cloud computing, one of the biggest mindset shifts isn't just learning services like EC2 or S3. It's learning where to go when you don't know something. And trust me, in the real world, you're constantly looking things up. And that's exactly why this exam objective exists, because AWS doesn't expect you to memorize everything. Instead, they expect you to understand the ecosystem of resources, documentation, support systems, partners, and tools that help you succeed in the cloud. And in real life, knowing where to find answers is often more valuable than knowing the answers up front. So with that being said, let's go. All right, so let's start with something real. If you've ever Googled something like how to configure IAM roles in AWS, or why is my EC2 instance not connecting, or what is AWS pricing for S3, then congrats. You are already doing what cloud engineers do. And the reason why is because AWS is massive. We're talking about hundreds of services, constant updates, and new features rolling out all the time. No one memorizes all of that. Instead, professionals rely heavily upon official documentation, community knowledge, support systems, monitoring tools, and partner ecosystems. And AWS has built an entire infrastructure around having you navigate all of this. All right, so if there's one place you should always start, it's with AWS's official documentation. The AWS documentation site is basically the Bible of AWS, because every service, whether it's EC2, S3, Lambda, or DynamoDB, has its own dedicated documentation with step-by-step setup guides, API references, best practices, architecture diagrams, and troubleshooting steps. So here's the key thing. This is always the most accurate and up-to-date source. In the real world, if you're working as a cloud engineer or IT support specialist, your workflow often looks like this. You run into an issue, you search AWS docs, you follow the guidance, and you fix the problem. That's it. Very simple, but very powerful. All right, so let's go a level deeper, because AWS doesn't just give you instructions, they give you strategy. And one of the first strategies is the AWS white papers. And white papers, these are long form documents that explain concepts like the well-architect framework, security best practices, cost optimization strategies, and disaster recovery planning. And these are gold for both the exams and real world scenarios. You also have AWS blogs, which are more dynamic because they cover new features that are released, real world use cases, and step-by-step walkthroughs. So if something new drops in AWS, then chances are it is explained in a blog before anywhere else. And you also have what is called AWS prescriptive guidance. And this is where AWS tells you, here's exactly how you should build this solution. So think of it as enterprise level blueprints for migrations, hybrid cloud setups, and security architectures. So if you want to level up from beginner to professional, this is where you start thinking like an architect. All right, so next let's talk about the AWS Knowledge Center. So let's go ahead and be real for a second. Sometimes documentation is not enough, and this is where community-driven resources come in. And one of those resources is the AWS Knowledge Center, and this is AWS's official troubleshooting hub. This is where you're going to find articles like, why can't I connect to my EC2 instance? Or how do I fix S3 access denied errors? And the stuff that you're going to find in here are practical real-world fixes. services. You also have something called AWS Reposts. So think of Reposts as AWS's version of Stack Overflow, where you can ask questions, answer questions, and learn from others' experiences. And this is huge because cloud problems are rarely unique, and chances are somebody else has probably already solved your issue. All right, now let's talk about something critical, and that is support plans, because sometimes Googling isn't enough. And AWS offers several support tiers, and the first one is your basic support tier, which is free, and it offers 24/7 customer service, access to documentation and white papers, and the AWS Health Dashboard. And this is what most beginners start with. Then you have developer support. And this is best for developers who are testing applications. And then there's the business support tier, where you get 24/7 support, and you get faster response times, and you get access to AWS Trusted Advisor. And this is where companies start taking things seriously. And then there's the enterprise on-ramp support, and this is designed for growing organizations where you get faster response times to business. And then you have enterprise support, which is the highest tier, and it comes with a dedicated technical account manager, and it offers proactive guidance and architecture reviews. So in the real world, companies, they choose support plans based on how critical their workloads are. And if downtime costs money, and it always does, then higher tier support will become essential. All right, so let's move on to talk about the AWS Support Center, because all support interactions happen through the AWS Support Center. So inside the Support Center, you can create support cases, you can track issues, you can access Trusted Advisor, and you can monitor service health. So basically, this is your central control panel for problem resolution. All right, so now let's talk about tools that help you avoid problems before they happen. And the first tool is the AWS Trusted Advisor. And basically, this tool gives you recommendations across 5 pillars. And those pillars are cost optimization, security, performance, fault tolerance, and service limits. So basically, it's like having a cloud consultant that's built into your account. And then you have the AWS Health Dashboard, and this shows you service outages, scheduled maintenance, and account-specific issues. You have the AWS Health API, and this is basically for advanced users, where this allows you to integrate health data into your own monitoring systems. So basically, in IT environments, these tools are critical for preventing downtime, reducing costs, and improving performance. All right, so let's discuss something that people don't talk about enough, and that is AWS has a trust and safety team. So if someone is using AWS resources for phishing, malware, or some illegal activities, then guess what? You can report it. And this is important because cloud platforms are powerful, and with that power comes responsibility. All right, next you have what is called the AWS Partner Network. So AWS, this isn't just a platform, it's an entire ecosystem. So exactly what is the Partner Network? Well, the partner network includes consulting partners, independent software vendors, and system integrators. And the independent software vendor, these are basically companies that build software that runs on AWS. And examples include things like security tools, monitoring platforms, and backup solutions. And then we have system integrators. And these are organizations that help businesses migrate to AWS. They design architectures and they optimize cloud environments. So just understand that in real life, many companies do not build everything themselves. They rely on AWS partners. And then we have what is called the AWS Marketplace. So think of the marketplace like the App Store, but for cloud solutions. And within there, you can find security tools, DevOps solutions, artificial intelligence, machine learning platforms, and cost management tools. And its key features are, it offers easy deployment, subscription-based pricing, and it offers integrated billing with AWS. And all of this helps save companies time because they don't have to build everything from scratch. So now let's quickly talk about the benefits of being an AWS partner. So if you're running a business or a consulting firm, then becoming an AWS partner does have major benefits, such as access to training and certifications, marketing support, partner events, and volume discounts. And basically, this is how companies scale their cloud expertise and offerings. All right, so next let's talk about AWS technical assistance, because sometimes you need more than support. You need hands-on expertise. Within that, you have some experts like your solutions architects. And these are AWS experts who can help you design architectures, choose the right services, and follow best practices. And then you have AWS professional services. And this is a paid service where AWS experts work directly with your team, help with migrations, and implement complex solutions. So just understand that in enterprise environments, all of this is extremely common. All right, so let me go ahead and bring all of this to life for you. So imagine you're an IT support specialist at a company using AWS. A web application goes down. Well, here's what you might do. Well, you're going to check the AWS health board to see if there's an outage. You're going to use CloudWatch logs to see what type of error exists. You're going to search your AWS documentation to help you understand the issue. You're going to check AWS Knowledge Center to look up any known fixes. You're going to go to AWS repos to see if you can get some community input. You may use a trusted advisor to help identify any misconfigurations. And then you may open a case in AWS Support Center if needed. And guess what? All of that is real cloud troubleshooting. Now, here's the truth. Passing the AWS Cloud Practitioner exam, this isn't about memorizing services like I've said 100 times already. It's about understanding the ecosystem of support and resources that AWS provides. So if you walk away with anything, it should be this. You do not need to know everything. However, you do need to know where to find the answers, and you do need to know how to get help. And you also need to know how to prevent problems, because guess what? That's what makes you effective in the cloud. And honestly, if you can confidently navigate AWS documentation, support systems, and tools, then you're already operating at a level that many beginners haven't reached yet. All right, so with all that being said, let's do some check on learning. So our first question is, a cloud admin needs step-by-step instructions to configure an Amazon EC2 instance and ensure it follows AWS best practices. Which AWS resource should they use first? Should they use AWS Trusted Advisor, documentation, the support center, or the health dashboard? And the correct answer is they're going to use the AWS documentation. So documentation, this is the primary and most authoritative source for step-by-step configuration guidance, best practices, and service-specific instructions. Next question. A company wants 24/7 technical support with fast response times and access to AWS Trusted Advisor. Which AWS support plan best meets these requirements? Is it basic support, developer support, business support, or enterprise support? And the correct answer is this will be business support. So the business support plan provides 24/7 technical support, faster response times, and full access to AWS Trusted Advisor. And our final question is, an organization wants to purchase pre-configured third-party security software that integrates directly with AWS billing and deployment tools. Which AWS services should they use? Should they use AWS Partner Network, the Marketplace, Repost, or the Knowledge Center? And the correct answer is AWS Marketplace. So Marketplace, this is the central platform for discovering, purchasing, and deploying third-party software that integrates directly with AWS.